Hello, hello. How was DConf? See, we got a different kind of programmer energy today. That's the hangover energy. Can you hear it? Do it again for the people back home. So now they do it louder because they're performing. Hey. Anyway, today is our third and final day of presentations.
Boo.
Boo.
Last day. Boo.
Yeah, but you get hackathon tomorrow.
Yeah.
It's not so bad, not so bad. What do we got coming up today? We've got the lightning talks coming up today. If you had a presentation that you wanted to submit, too late. We've actually filled all the slots, so you're going to have to do it on one of the online beer comps instead. I don't think we have much housekeeping to do this morning, so let's just get right on with it. Attila, have a rant about whatever you're ranting about, please. And programmer energy now, please.
So I had this idea for the talk because somebody in the forum said something I disagreed with, and then I realized I have a bunch of pet peeves. So I'm just going to rant for a bit and tell you what you're doing wrong. So these are my opinions, so they're not facts. And whenever I say do this, don't do that, basically mentally preface it with, in my opinion. But that's boring, and also it's a lot of typing, so I'm not going to do it. And so I'm telling you right now. Now, my PhD supervisor told me ages ago that an expert is somebody who's made every mistake possible. So that an expert is somebody who's made every mistake possible. Now, I'm not calling myself an expert, but the thing is that my opinions are here for a reason. I banged my head against the wall, and now I'm trying to prevent you from banging your head against the wall. And rule number 0, for me anyway, for programming is always use your head. That's why we pay the big bucks. Think about things, understand what the trade-offs are, and make a decision. So don't cargo cult any of this either. They're just guidelines. Always actually think about your situation. Does it apply or not? And of course, it's more than okay to disagree with me. Sometimes I'm an idiot. And to frame as well, the guiding principle of all this is that refactoring for me is key. Nothing you do in a 200-line script that you wrote yourself and nobody else is going to see matters. It doesn't matter. You can use global variables, you can use go-tos, it doesn't matter. Because all of the engineering principles that we hear about is when you have thousands of lines of code and there's multiple people working that code base, now things start to matter because it just doesn't scale otherwise. So refactoring is key because you're going to have to change your code. If you're not changing your code is dead, nobody's using it, it's useless, which means, of course, nothing matters at that point either. Because a project that doesn't have people finding bugs in it isn't being used. It just isn't. It can't. Even if you wrote the most perfect thing ever, your users could be idiots and don't understand what they're supposed to be doing. So one way or the other, you're going to get bugs, so you need to fix them. You need to change things slightly. Situations change, your environment changes, your code needs to change. And when your code needs to change, then we want to make that change to be easy to do, not hard. So everything I'm going to talk about now is because I think, well, not everything, but a lot of these things is refactoring is key. So whatever makes refactoring easier is good. Whatever makes refactoring harder is not. And the moral of the story is that if you take anything away from this talk at all and forget everything else, is that the API is paramount and the implementation is absolutely not. Of course, except when it is, but you'll know, for instance, if it's slow or buggy, that kind of thing. But modulo those things, the implementation doesn't matter. I should be able to completely and utterly change it, and you won't know as long as the program does what it did, i.e., if the test still pass, then you haven't broken anything. You should be more than free to change implementation. The API, however, is what really matters because that's how your users interact with the system. Whether it be a REST API or a command line interface or an actual API that you use for programming, that's what you really care about. Implementations don't matter. So, stop writing classes. And why? Because, well, first of all, no, it's $1 billion mistake for a reason. You have this weird value that all the types, also participate in. I don't think I have to talk about the problems of null. Everybody's hitting these problems before, and you get it whether you want to or not. Sure, you can put class in the stack, but that's not usually what you do, and you get null. Reference semantics are terrible. I don't want to be poking something here and then having something come out over there. But that's what you get with reference semantics, and that's what you get with classes. And why would we have that? It makes sense. Because when you have runtime polymorphism, you don't know the types that you actually have at that time, which means you don't know their sizes, so what can you do otherwise? You pass a pointer. But this is what you get baked in whether you want to or not. That's not a good idea. So if I see a class that has no child classes and doesn't derive from anything, why does it exist? I don't know either. Use a struct, it'll be better. And of course, there's an asterisk there because unless you actually need runtime polymorphism, in which case, yeah, write a class because they don't really have many options otherwise, but don't. And we only use reference semantics anyway when we are trying to avoid copies, because that's why we do const ref and C++ all over the place. It's to avoid doing a copy because copies are expensive. But we don't actually want reference semantics. We want value semantics because that's easier to reason about and you don't get spooky action at a distance. Sean Parent even did a talk in which he was illustrating how he got the best of both worlds by using a shared pointer of const t. That way, you can't really mutate things, so you don't get action at a distance because you can't change it. And what you do is just change what the shared pointer is pointing to, which is fine. But reference semantics, as in classes, as in D, not good. And you pay for things you don't need. At work, we have external C++ classes. We're not using them to interface with C++ at all. It's just decode. Why? Because we don't want to monitor. So that's already showing that that wasn't a good idea. And you don't even actually need classes in the language like I've mentioned before, because I wrote a proof of concept showing that with reflection and structs, you can get the same thing. And if you really, really, really want a reference to something, new it, you can pass a pointer to a struct if you really need to for some reason, but don't, just pass it by value. Unless, of course, you profiled and it's slow, in which case. But, at that point, you actually have a reason to not preemptively, oh, I don't want copies. Why not? Does it matter? Probably not. Why is the thing not working? Right, private. Use private everywhere. Private is good. Private, friends don't let friends write public everywhere because that's a bad idea. I would treat your code implementation definitely like your underwear drawer. Do you want random people there? No, you really don't. So put private everywhere. You don't want random people in your privates. And API design needs to be explicit, not implicit, not something that you have to explicitly say, I want this to be public, I want it to be private. Well, you do, actually. You don't want things that happen to be your API because you happen to write some functions. I see a private function in the module and it's not used anywhere, I delete it because it's useless. If it's public, I can't. Oh, I can grab the rest of the code base. Okay. Unless your code base is useless, as we mentioned before, somebody's using it. How are you going to grab their code bases? Do you want to break things? No, because then you'll get angry users complaining at you. And if your clients can do something, they will. And therefore, you need to support it, whether you want to or not. And you probably didn't. And just like you shouldn't get married to random people you meet off the street, don't get married to all of your users by promising things that you don't want to in the first place. And yeah, so for private functions deleted, does it make a sound? No, just delete all the private functions that you see aren't doing anything. So I think these are the reasons why I think private is a good idea, because again, I should be free to change the implementation, and if it's not private, I'm not allowed to. Don't test private functions, because why would you? If the behavior you want isn't detectable through your public API, what are you doing? What is the point of the thing you're testing? I'm testing a private function for a reason. If that private function isn't being called by your public API, why does it exist? Don't even write it in the first place. Now, sometimes, especially if you're doing TDD, maybe you're uncomfortable with the fact that you're writing a function without explicit tests for that function, and maybe it's really small and it kind of looks cool. Okay, but in that case, be willing to delete those tests. And for most people, this feels icky. Like, I don't want to delete them. Delete them. Delete the function, delete the test. Deleting code is great. Just, as long as your test pass, and as long as you're not deleting the tests themselves, delete stuff. Red diffs are the best diffs. And think carefully about your dependencies, because I see a lot of code out there that everything imports everything and everything depends on everything. Phobos. Don't do that, because it's a bad idea for multiple reasons. It's harder to reason about. It's harder to find where things are defined. It's just harder to find everything and think about it. Cyclic dependencies can be bad for multiple reasons. You can get problems with module constructors, for instance. And one thing that I don't think a lot of people talk about or think about enough is the build system itself and how long it takes to build things. Because if everything depends on everything, when you make a change, everything needs to be rebuilt. And that's probably not what you want. At least for me, I want to rebuild the fewest amount of things possible given any change I've made. And so I think it's a good idea to think when you're writing a function or a type, where does this go? Where should it go? Where should it be visible from? So, you know, what package should it go into? What module should it go into? And an example from DPP that I've got here is that I have a package module called type. And the only reason for its existence is to manage dependencies, because I don't want everything to be rebuilt all the time. So for the people who don't know, DPP does translations of C and C++ headers into D code. And the translations, of course, basically recurse, because if you have a struct, then you go into its members, and then you recurse into that. And so there's translation for things like enums and for macros and for functions. But there's also translation for types, basic types, and things like that. So all of the other translations I just talked about depend on having to translate types, but not the other way around. And so I don't want that package module to be compiled with everybody else, because if I change it, they have to be rebuilt, but not the other way around. And if I hadn't done this and lumped it all together, I would get worse build times for nothing. Now, having said that, the reason why my build times are the way they are is because I build the code per the package. And the reason and how I do that is because I use reg instead of dub normally, and that's the default, and it's a default for a reason, because in the benchmarks I did way back in the day. And so it's unfortunate that because most people use dub and build all at once, they won't even get the benefits of that anyway, because you change one module, you rebuild all of them. But that's not a good thing, and something that we need to change in dub anyway, so that everybody gets the benefit of that. And I would think of D packages like object-oriented class hierarchies, in the sense that if it's too deep or too wide, then you're probably doing something wrong. So if you only have one D package in your program and there's 20 modules in there, rethink your life decisions. Local imports, or imported that's been in D runtime for a while now, basically to avoid any global imports of any kind. Why? Because again, just like location, it's refactoring, refactoring, refactoring. Because I want to be able to just cut a function up, move it to somewhere else, because again of the dependencies we just talked about. And is this function really supposed to be here? Is this the best place it can be? Because if I'm importing a bunch of stuff from somewhere else, maybe it should be in that module instead. And so I want to be able to move functions and not care, instead of figuring out which imports I need to take with me, which might not be trivial. And because of dependencies, like I mentioned, and somebody could say, as somebody has mentioned in this conference, well, what about tooling? I don't care. Just let the tools do their thing. Well, first of all, I think that language design that depends on tooling is bad language design. And I haven't seen any that work properly yet, but I could be convinced otherwise if I do, and one exists, but I'm not aware of them. But the other thing that tooling won't solve, well, maybe it will, if you do local imports for everything, is that when you have global imports, it hides how bad your function is, in the sense that it has too many dependencies, because you can't tell. Now, if you do have a lot of imports in a module, then your module is definitely doing something wrong, because it shouldn't be having all of these dependencies. But it's a lot easier for me, at least looking at a function that's importing 20 different things, that this is a code smell, and there's something that's really definitely going wrong here. And it's a lot more explicit that way. And again, dependencies are bad for multiple reasons: comprehension, build times, etc. If you're caring about endianness, and you're not writing a compiler backend, and you're not actually encoding something, you're 99.9999999% definitely doing it wrong. you shouldn't care. You definitely shouldn't care. And Ati's laughing because I've already told him that earlier this year, last year, I can't remember. It doesn't matter. CPUs do what they do. If you use the operations that CPUs know how to do, like shifting bits and ANDing and ORing, they do that. That's literally what they're supposed to do. It doesn't matter what things look like in memory. Let the CPU care. Why do you care? When I was younger, I never understood the host and network macros and vice versa, because I don't understand why they exist. There's no point. Just don't cast things. Don't cast pointers. Don't reinterpret them, and you'll be fine. For instance, the code there takes a big endian encoded stream, which is a very different thing from caring about the endians of your CPU, and takes a 32-bit integer and then decodes it into a 32-bit integer. That's the code that would work in a little endian machine. The code that would work in a big endian machine is exactly the same code. There's no point of making a version this and then doing that. It's completely useless. It won't work. But then you might say, well, what about performance? If I'm on a big endian machine, I could just cast the pointer and there I go, right? Guess what the compiler does when it sees this? Don't try to outsmart it. It's fine. Also, you profiled, right? That's why you care about this. Because if you didn't profile, why are you caring about this? You're doing it wrong. Walter has a question.
As it turns out, the compiler optimizers recognize expressions like that, and if the endianness matches, it just generates a load.
Yeah, exactly. So stop trying to optimize things that probably won't matter anyway. I've literally run a profiler once in my whole entire life, and the bottleneck was where I thought it would be. Every other time, it's like, what? I still remember the function that caused my first bottleneck by name. It was printf. Don't print things. It was the lesson there. Also, mixed endian machines exist. I had to work with one once where the floating point was, I can't remember how, but basically the 64 bits were weird. Like you divided it into two 32-bit portions, and those were swapped for some reason. Don't write auto, because auto is mutable, unless you put a const on the other side, which you probably won't be doing. So don't write auto, write const. Const is good. People keep saying, I can't use constant D. Well, I don't know what you're doing wrong, because I keep doing it all the time and it works. So do const. Also, if not const, probably use scope, because sometimes the inference doesn't work. And that's unfortunate, and that's definitely something we should work on. And the users should not have to care about writing auto scope, but in practice, that's what happens. So use one of those two. But definitely don't write auto to mean I want to write explicitly the types on the left-hand side either, because that's over-constraining. You don't care about the actual types. I know some of you are already feeling something in your gut saying, but I do. No, you don't. No, you don't. Why? Refactoring. Again, you don't care about the actual type. You care about the API. You care about what you can do with that type. That's what you care about. Now, unfortunately, auto under-constrains things, because you don't actually want auto either. Because what would be great is somehow saying, what I want is this, which you can do with classes, of course. You can use an interface instead, and that will be the lowest common denominator, and that way you can change what the implementation is without having to change the declaration. But if you're using templates or something like that, that's different, and we unfortunately don't have a way to express that. What would be really cool is if we could do something like input range of constant, this thing, and then assign. Because then you don't care what actual range is. The type won't matter. The implementation doesn't matter, but this is the API. This is the interface. I want something that behaves like an input range of const integer, which also should be easier to write, because when people say, I can't use const for ranges, the range itself can't be const. But do you care? Because when you use arrays, what you write is, or could write, is an array of const something. And it should be easier for me to say, I take a range, but it should be a range of const something, because I'm not actually going to mutate things. And const is good for code comprehension, et cetera, all those good things. So I don't know how we can get to this promised land here, but that would be amazing.
Okay, what do I do if I want to mutate a variable?
Sorry?
What do I do if I want to mutate a variable? Do I just jump off a bridge right there? Or?
No, sometimes the easiest or best code is to mutate. You know, sometimes algorithms are better expressed that way, and that's fine. What I'm saying is that shouldn't be your default go-to. Like, you know, your muscle memory should be writing const, and then every now and again think, oh, I can't that right now. I'll use auto. I think that unit tests should, by default, again, muscle memory, you should be, in fact, it is mine. I never write naked unit tests. It's always @save pure unit test, and then if I can't, I'll change it. In fact, I think that, you know, for most tests, they probably should be able to be run at CTFE. Because I don't want to pay the linker price. I don't want to link code. All of that is already boring me just by talking about it. The only thing I care about is running my test as fast as possible. I want a way that optimizes for the time it takes to parse semantic analysis, figure out what I need to do, run the test, give me the feedback I need to know I haven't broken anything, and if I have, oops, I'm an idiot, go back to the last save point. I would love for something like what we saw in Neat, where the compiler is the daemon, and it's just listening, and I do my changes, and then it just goes, run the test. And only the tests that have changed, because the compiler knows what nodes are affected, given the changes I just made. That would be amazing. So I don't want object files. I don't want anything to be written to the disk. All of that is boring. Delivering binaries to customers to me is very, very boring. I don't care. It could take an hour. I'm fine. What I care about is my development workflow. That's the only thing I care about. So, and my test should be able to, be run fast and also not have side effects, and et cetera, because if they are like that, it means the API is usable that way, which means the API is probably good, it needs to be tested, and et cetera. And I write the test first anyway. But of course, this is not always possible, and sometimes it's not even desirable. For instance, if you're writing a translator that takes C code and produces D code, like I have, a really bad test would be to say, given this header, I want you to generate this exact string. This is a terrible test, because if I change the formatting in any way, shape, or form, the test breaks. But I haven't actually broken anything, and that's not a good test. And so the only way you can really figure out if the code you generated is doing the right thing is to compile it. Because what you're trying to do is actually feed something to a decompiler. You have to use a decompiler at some point. And the way I do that is by usually doing a static asserts, because that way I don't actually have to run the compiled code. I just want to assert things about the code I generated, like that the struct is this big, for instance, so the third member is an integer, or things like that. So when you're having to interface with things like that, it's just not possible for you to write, a nice little safe, pure unit test, because you literally just have to interact with it. If you're producing make files from a build system, the only way to figure out if your make files work the way you think they do is to run make afterwards and make sure that the behavior is what you expect it to be. So it doesn't always work. Point is, this should be your go-to. This is what you should want to do, and then you feel bad for yourself whenever you can't. I also think that test taxonomy is incredibly boring. I don't care what people think is a unit test or integration test or a system test or whatever test. Who cares? I only care about the following things when I write tests. These are the characteristics that I want them to be. Fast, so I get the feedback as quickly as possible. Consistent, so reproducible. They either always fail or always pass for a given commit hash. Flaky tests are bad. Flexible, which I mean by being the opposite of brittle. So the example I gave before about comparing exact strings, don't do that, because it's a brittle test. It breaks for no reason. I want the test to break if and only if I have broken the code, which gets to also the test should capture the actual behavior of the thing that you're testing and not the implementation, because the implementation could change because it doesn't matter. So the worst test I've ever seen in my life was something that mocked the function it was testing and basically line for line asserted that that function was doing exactly the thing it was doing. What is the point? It's a one-for-one representation of this. It will break if you do anything at all to the code, and it doesn't mean anything. And it's not testing anything. I mean, should you be calling this function with these parameters? I don't know. Like, actually verify that you sent a packet with this content, not whatever this thing is. And really try to not write tests that depend on the network. They will be flaky. It's just a matter of time. And if you have one test that has a failure rate of 0.1%, you might not care. your code base will grow. You'll have 1,000 tests. Oh, look, now you have a test failing every single commit. It's not a good idea. And as an example of, I can't write a pure unit test because it won't do. As I was mentioning before with a build system, this is one in Reggae, which produces makefiles. In this case, it's using the makefile backend. And to explain what the code does, I'm using a sandbox. So this environment is one in which I can just create files and not care about where they are, not care about the name of the directory. Just give me one. I just want to write some files to disk and then verify that some things happen. In this case, actually, it's smarter than that because it says Reggae sandbox, and then I'm feeding it a string called dub. That's because there's a directory called dub in the project, and it's reading a dub project for there, and then copying the dub SDL and the source files to the temporary sandbox, because I don't want to dirty things. And then it runs Reggae itself with those command line arguments to produce the makefile. And then that function make just runs make with those command line arguments because I want to make sure that the compiler flags are the ones I expect. It should execute OK, and it should contain in the output -g-debug because I'm doing a debug build and dub, so that should happen, OK? And then basically what this S is doing is that if I change the dub selections.json because the dependencies might change, that Reggae reruns itself to re-output the new makefile. And so I touch the file that's in the sandbox path, and then I verify that make runs again. If I run make again, it contains Reggae in its output because it's rerunning Reggae to then recreate the makefile. Why it fails there is something I don't need to get into right now, but I thought it was a good example of showing that, yes, I'm telling you to write pure unit tests, but I also don't because sometimes you can't and you shouldn't want to, and it's OK. Don't write for loops. I mean, I copied this from Sean Parent, but he's right. 99% of them, which is a number I got on the internet that I made up myself, of loops are either map or filter or fold, and I don't want to have to read your code to figure out which one it is. And you might introduce bugs by re-implementing them yourself. Why are you doing that? Don't do it. Use map, filter, and fold. You'll be fine, and so will I when I read it. Yes, sometimes it's a lot easier to express an algorithm as a for loop, so you know, it's like I said before, rule number 0, use your brain, figure out what works best for you in this scenario, but you know, your go-to should be ranges because you know, they're good. And yes, sometimes it's performance issues, but you profiled, right? No? Then why are you worried about it? And parallelism can make this worse too, because can anybody spot the bug there? This is a bug. Nobody? Yeah, data race. Now, this is a bug that we need to fix ourselves because basically the lambda that's getting passed to the for each, the context pointer there should be shared so that we can't do that, right? Because I'm appending to the thing, the threads are writing to the same pointer. That's not a good idea. So don't do that. Do you know what works instead? A parallel, you know, map or filter or reduce, whatever you're doing in that case. And the reason I know this is because I wrote this bug and then realized later, and I went, oh, don't do that. I think main should be mostly empty. Nearly every single one of my main functions looks exactly like this. I try to run, real main is called run, and it takes, you know, an array of strings just like real main would, the main. Yeah, I don't know what to call them. And then return 0 because, you know, everything worked. And if there's an exception, log it, return 1 to the operating system, let the user know that something failed. Now, why? First of all, because I don't want to have a bunch of code that's being lost in a try block that's, you know, this big, maybe. Secondly, because it makes testing a lot easier. I used to use Cucumber for behavior-driven development. You know, given these conditions, when I run my binary with these command line arguments, then this should happen. Because I thought that was the easiest way for me to take my final binary and then, you know, test that. For instance, the user got an error message that stated, you know, I can't copy this file because it doesn't exist, for instance. So there would be a test for that. And it's just a lot easier if you can run test it with a unit test block, and you just call run instead, because you can't call main from a unit test block, but you can call run. The other reason this is important is because it's trivially simple to make your binary into a library. Don't have this main function. It's called run. Look, it's a library now. Because main is evil. So, I put it in its own file because it deserves to be shunned and ostracized. And also that makes it really easy in Dub to say, just forget this file. I'm a library now. And it's just easy. So I think every binary should be a library because at some point somebody's going to want to use it in a way that you didn't predict, and this just makes it possible. So I think that putting it in its own file makes it even easier as well. There's a question there.
Hello. Yeah, I just want to point out, in addition to that, which some people don't realize because you're not paying enough attention, is with Dub in specific, if you do not split everything out of the module with main in it, your unit tests in there will not run because it replaces main to run the unit tests. So one of the issues with Dub then exacerbates this problem such that you definitely don't want to be putting all that code with main.
Right, so there's two issues there. One, that Dub is doing the wrong thing, and two, that so are you, because you're not using TDD, because if you were, you would have noticed the tests weren't running.
It's actually even worse because you don't even notice compile errors in main.
Sorry?
It's actually even worse because even semantic errors in main won't show up if you run dub test.
So yeah, I think this is a good pattern. I encourage you to use it. I don't know why I would go back to having a main function that's an actual main function instead of this thing, because also it means, you deal with exceptions is this is how I handle them. Like, what else do? I don't know. So I catch them here. There's no catch blocks basically anywhere else. Or what I care about, especially if it's a binary and it's actually taking command line arguments, is what does the user see? What are the error messages?
I wanted to say I use the same idiom, and it's a templatized on the function itself.
Oh, okay.
My main is a single line, meaning try whatever my function is.
Yeah, that makes sense. I hadn't thought about that. And again, with the error messages that I'm talking about, the tests are trivial to write. What you do is you call run, and then you assert that you threw an exception with the message, whatever it is. Because I don't think people do enough tests for error messages, and they should. Even logging sometimes, because it's like, how do you test the logging? Well, like this. Don't write complicated continuous integration configurations, because if you have a YAML file that's 200 lines long, how do I run that on my machine? There is no way. Unless you can spin up a container that does the exact same thing the CI does, then yeah, sure, knock yourself out. But otherwise, if you can't run things locally and you depend on CI, that's usually a bad idea. There's a bunch of people also depending on the same CI. It will take longer. You can't just run the tests you want. The workflow should be run only the tests you need to run, and then CI will run everything else just in case, your particular mental algorithm for what needs to be rerun right now didn't work. It's more of a fallback thing than anything else. At least that's how I work. But then again, as some of you may know, my pain threshold for getting feedback is about 20 milliseconds. I'm not exaggerating. Anything more than that will make me angry. And you wouldn't like it when I'm angry. I won't turn green, that's fine. Scope exit is intended to make things easy and easier than writing a type with a destructor and using RAII, because sometimes that's overkill. I don't want a new type cluttering things, and also it's over here, and I'm over here, and I can't even see it. Why am I jumping to definition when I don't need to? So the intended usage is, for instance, when you have a C API and you need to set something up in the beginning, and then make sure you shut things down later, you just do the thing, and then scope exit, do the other thing that I need to do to shut things down, and then you never see that again. If you have a bunch of scope exits everywhere doing similar things, write the type. It's a lot cleaner. And you can use with as well to scope the thing, and then you can even have a better API inside of there because you don't need to keep referring to the thing by name. In fact, we saw that in a previous test with a sandbox. That's exactly what it does. Because at the end, it cleans up after itself. And it's easier to write the files and read and do the assertions you need to do. So if you're doing scope exit all over the place, you're doing it wrong, write the type. The intended usage for this, so. I don't understand why people like empty parentheses and function calls. It makes no sense to me. I'm lazy. Why would I type the parens? Why? Just why? Oh, I want to make sure it's a function call. Why'd you care? You're reading a value. Maybe it changes over time. Maybe it doesn't. Why'd you care? It's literally what it is at that point. It takes no arguments. It's a value. But it doesn't matter. It's a value. Also, it hurts refactoring, because what if I change it to an actual value? Oh, right, I need to take the parens off. Why are you doing that in the first place? Don't. So I want to be able to write things like an infinite range that has an enum empty equals false, and things work. So don't put parens on it. Why would you? It's extra typing, it's extra reading, it's 2 more bytes in your file. Who cares? And I saw that in slides 2 days ago, and I went, ugh. Don't write getters, and absolutely do not write setters.
One thing why you would put parens is that people that are not coming from a deep background, they don't really understand what's happening there. So putting parens clarifies that for them.
I don't think anybody has this problem in Ruby. So I'm not sure that's an actual issue. So getters for me are a code smell, and setters are a code stink. And the reason why is, why do you want to know? Why do you want to go into internal state of another object? Instead of asking it for things and then doing decisions, just tell the thing to do it. Do not ask, tell. The whole point of object orientation, as it was initially designed to be, is passing messages. Passing messages doesn't mean you get an answer right now. Just send it a message, go fetch my lunch. Not, oh, what's your menu? No, just do it. Just do it now. So this is a silly example, of course, because it's a slide in a talk. But, oh, I want to know it because I want to print it. No, you don't. Tell the thing to print it. It knows better than you anyway. Why are you reaching in? The whole point is encapsulation. And again, I might change implementation. Maybe I'll do it in a different way. You shouldn't have to know, and you shouldn't break. So, tell, don't ask. Yes, of course, if you go grep right now over my GitHub, have I written getters? Of course. Have I written setters? Of course. But that shouldn't be the default. Look, everything here I've done, and will probably continue doing, because I'll say to myself, oh, it's fine, I know what I'm doing, and every single time I live to regret it. So if you're writing getters, like, oh, this framework makes it really easy to write getters and setters, stop doing that. Don't do it. Don't make it easy. Don't write them at all. Java beans were a bad idea. Don't use shared. Hey, how do you use shared in D? The answer is you don't. Use a framework. Use Sebastian's library and do that instead. Have somebody worry about the implementation where shared becomes a thing. Don't use it yourself. Or especially if you have a global variable, don't use gshared either. That's a terrible idea. But if you have a global variable and it does need to be shared among threads, can you make it immutable? Because your problem is solved. So if you're reaching for shared, think twice. Maybe you need to after all, but you probably don't. And if you can make it immutable, your problem is solved. Now, it's true that sometimes making things immutable is a pain. And it's true that sending something to another thread should be allowed if you can guarantee that nobody else has aliases to it, but we don't have a way in the language to do that right now. If we could, then that would also solve the problem, because it's not shared mutable data. It could be mutable if it's not really shared because you sent it somewhere else, and I don't have it here. So that's something worth exploring, I think. And a conclusion to this is that, to reiterate what I said in the beginning, the API is paramount. That's what you should care about. It should be simple, should be small, so you have less surface area to test and for people to get things wrong and to write bugs and etc. The implementation is not something you should want to care about unless you have to. Again, if it's slow, you have to make it faster. If it's taking up too much RAM, you need to avoid doing that and avoid allocations and that kind of thing. But it should be the case that if your test pass, you don't really care what's going on under the hood unless you really have to. And if you do have to care, then re-examine your life decisions. And refactoring is key, because Code that isn't being changed is dead, and if it's dead, why'd you care about it anyway? Thanks.
All right, question time. Raise your hands if you got one.
So I have a brief question about like getters, setters, that kind of stuff. I'm calling some API on the web. There's maybe 40 different parameters I could pass in, but maybe only 2 are required and the rest are optional. How do you propose calling that? Because it sounds like you're saying I can't really make an intermediate object because I don't want getters or setters. So what's the proper way to do this?
Again, maybe the easiest way is to do them, but I would say in this particular case, the builder pattern.
Isn't that like built around getters and setters?
Yes, but you're removing the ickiness and putting it over here, if that makes any sense. Like that's the only reason for its existence anyway. It doesn't do anything else.
All right.
Yeah, going one step further on that, actually, you pretty much don't need setters if you have that in a framework. Like, you shouldn't be setting properties on a variable. You should be replacing it with a new variable that you
Sure.
mutate in a
Yeah.
certain way.
That's also a way to do that, sure. And of course, that makes reasoning about your code easier because it doesn't change. If somebody has an alias to the old thing, that doesn't change under the hood. Value semantics.
Yeah, side note, if you're using boilerplate, it does that for you automatically.
You said that we should not use shade if possible. What if I say, okay, I use _ gz instead?
No,
What's
don't
your
do that
comment?
unless you have to because you're interfacing with C or something. Just don't do it. I mean, sometimes, or you're writing a kernel, like we saw in a good example of that yesterday. But again, rule number 0: think first. Maybe you need to. Maybe this is the easiest thing. Maybe you got better things to worry about. You know.
In fact, about that kernel thing, that's where I think shade is a good use case. When I did the 8-bit experiments I wrote about in forum, in fact, the exact thing I did, I didn't use gshade. I instead made it shared and cost it away in the functions that really needed the global.
Sure. Again, it depends on your use case. Think about it. Guidelines. Don't cargo cult things because that's a bad idea. I worked on a project once that had, so the project was called SLA, and there was a hash defined that was SLA_2, TWO, and it was defined to 2, just in case the number 2 might change, I guess. Because you can tell how this happened, right? Somebody wrote a 2 in the code base, some reviewer went, magic number, define SLA2, SLA2.
We have an online question from Ricky. Do you think it is acceptable that we have to expose internal details like locking outside of a module because export is a visibility modifier?
I don't know.
There you heard it. He does not know. Anybody else with a question?
How do you use const correctly? Because as soon as you try to complicate things with ranges or stacks of structs, you get into a load of pain. So,
Well, if you get into pain, you know, the old joke applies. Doctor, doctor, it hurts when I do this. Don't do that then. if it's causing you pain, don't do it. I mean, think about if there's a better way of doing it, and if there isn't, then do that instead. You know, go about doing your job and don't worry about it too much.
Follow up on the same question. So I call a third-party library that I don't own. They don't use const. What do I do?
Then, unfortunately, you can't. But that's the reason why I said keep using constant declarations. Is something I actually forgot to mention, is if you keep doing that in unit tests, you have to for your own code, because otherwise it won't work with const objects. So if you keep using them, you have to actually add const at the end of the member functions. So, but of course, if you have a dependency that doesn't, what are you going to do?
Just as a word of warning to those who are actually trying this, if you if you try to declare your types as const, or if you, it's like for your structs, for instance, or you declare them as immutable, about half of standard algorithm breaks.
I would say to not declare the types themselves as const, because I don't think you should limit what your clients should do with your code. If they want to use a mutable version of it, why shouldn't they?
All right, let's
you
do
can't
one more question.
anticipate, you know, what they're going to need to do. So
Let's do one more question. Who's got a good one? Not accepting bad questions. Who's got a good question?
On your wrapping main and then you in the run, would you also pass in stood in out an error through as well, so that your streams you're never writing directly to stood out, so you can capture them in time?
I would not do that. I think, well, first of all, I think things like printf and write-ln should not be used ever. And the reason for that is global state. What you should be doing is passing some object, or a file even if you really want to, but normally what I do is I do a template thing because I don't want to constrain it to be a file object. It could be something else. And that would be what you do .write-ln to. That way, you can pass stdr and stdout in the wrapped main, so that was uses in the real implementation. But then when you're testing, you can just append strings and assert that the output was this.
What I've been drifting towards over time to address that is to pass in a sync parameter. So all your messages go there, and that means the caller decides what to do with it. Can throw it away, can write it to a file, can write it to stdout, could write it to stdr. It's entirely up to the caller. The engine itself shouldn't need to care where those strings go.
Yep. Yeah. Sure.
Yeah.
Yeah. So main would pass in stdout and stdr, and then. Yeah, exactly.
All right, then we're done here. So thank you for the rant. All right, so we have the next talk in, what is that, 13 minutes? Go have coffee, go have your hangover cures, go do whatever it takes to be ready for the next talk.
Yeah. Can I put my me a photo.
Okay, everybody, back upstairs. We got a challenge for you. See how awake and alert you are. See this title up here, Internationalization with Get Text. Say it 10 times fast. Now, go. Yeah, they've lost it already. They've lost it. Yeah. So it's good that we had this one. You know, we know that they were only slightly alert, I guess.
Yeah.
All right. Just a little bit of a note for the audience. When it comes time to question times again, I'm managing like 3 microphones and the internet, so wait until I point to you before you start asking your question. Everything will go much smoother as a result. Okay, but now with that little bit of housekeeping done, I think, Bastian, you can get on with your talk, please.
Thank you.
Programmer energy. Come on.
I want to start off with saying that I'm really glad to be here, and the conference has been great. Lots of interesting talks, wide diversity, and it's been very interesting. And now on to the least interesting topic of this conference. It's internationalization. And what does that mean? It means to prepare your products for an international audience, an international customer base. And for software, that means supporting your user interface in multiple natural languages. And if you've been exposed to internationalization as a programmer, I bet you weren't very enthusiastic about it. Why not? Personally, I'm a naval architect. I like solving problems for that regard shipbuilding, and that's what motivates me. And internationalization is just not in that set. It's just an annoying user specification that needs to be met somehow. So I'm going to present a project, a dub package that I wrote, that aims to make internationalization as much of a breeze as possible. And I think that might be interesting. The package of which you see the logo in the top right is called GetText, after the well-established GetText system, which is more of an ecosystem, and this package lets you tap into that. And I should mention that I didn't invent the ideas that you'll see presented here. I just did the work, and others deserve a lot of credit, but more on that later. Let's start with a poll. I've seen people doing that. It's always great for engagement. This being an international conference, raise your hand if your native language is not English, or if you live in a country where English is not the native language. Oh, wow, that's maybe 80% here. Great. So all of you know that, maybe not yourself, but at least you know people that prefer to interact with their devices and systems in their native language. And even though English is the lingua franca of computer programming, the annoying fact is that if you want to increase your customer base, you'll have to deal with internationalization at some point. In this talk, I'll be giving an example of how you internationalize your code using this package. And in the end, I'll highlight some of its implementation and how it uses D features to achieve its magic. Before that, let's quickly review the ways in which internationalization is tackled in the industry to get an idea of the state of the art. I'll start with what we have been doing thus far, and I'm not too ashamed to share this because we could have been in a worse place, as we'll maybe see later. As I've presented in previous tasks, most of our decode is machine translated from Pascal. In Pascal, we were used to do everything ourselves, and so we have been using a homegrown system for internationalization. And that system translated the complete source code. So we were building a different version of every program for all languages that we support. This comes with a myriad of disadvantages, but the fortunate case of our situation is that since we're transcompiling anyway, we might as well transcompile to a different string syntax that allows us to use a different system for internationalization. So we can just pick and choose the best one. As it turns out, there are solutions that are platform-specific, language-specific, and framework-specific. And I'll show one of each category. Although we prefer to be platform-independent, Microsoft Windows has been strong in internationalizing its products for a long time. So let's look at their Hello World multilingual user interface example on Learn Microsoft. Yeah, apparently internationalization is not trivial. And you can scan the QR code on the top right if you want to have a closer look. And that code will change on the further slides to get you to the link that is relevant for that slide. So let's zoom in to the top and see what it starts with. Hash defined sufficiently large string buffer. Max path times 2. Okay, let's scroll down. Luckily, there are a lot of comments, because otherwise you wouldn't be able to make sense of it at all. And I'll treat a beer to anyone that spots the string that is actually being translated. I have no problems making such promises because it's not here. There we are. So this is where the meat is. Let's see. There, you use load library to dynamically load the resource of the specific language. And here you have a buffer of white char that is of sufficient size. And then we use load string to fill that buffer. And there. And how do we know what to fill it with? We fill it, you know it by an idea. There, hello, mu string 0. All strings that you see in this code are untranslatable, and the only translatable string is hidden behind an identifier. Then the example shows how to format the buffer with a translated string into there another buffer. And that buffer is displayed in a message box. All right. Hope you've been following along. This is a very good example of what not to do. That's what I meant. This, from a programmer's perspective, this is way worse than what we have been doing. And the biggest problem is that you don't see the contents of the translatable string. It's just an ID. You have no idea what it represents. I'm guessing it means hello. And another interesting thing, what do you do if you can't find the translation of that string? You tell your user, sorry, can't go on. We just terminate the program. And there are no plural forms, and plural forms are an interesting aspect of internationalization. So moving on to a language. First I looked at C#, but it's the same mess. This is Java, and it's very refreshing to see an example that fits on one slide. And the important thing is just these last 4 lines. You load a resource, you look up the strings, and you print them. It's a bit verbose, but maybe Java people are used to that. And very nice is that the key is actually a string. So it's all good then? Sadly, no. The tutorial stresses that the strings in the code, here greetings, inquiry, and farewell, they're definitely not the strings that are displayed in the user interface. So they're just keys, only in the form of a string somehow, for some reason. And that comes clear if you see actually the translation table. That's the translation table used in the example. And I don't think you can use white space in the key or equal signs. So that's limiting. And the tutorial is not clear what happens if you can't find the string. I think an exception or something. The last reference that I want to review is the highly popular Qt framework, or Qt. And it goes like this from the Qt documentation on internationalization. First example is if you have a string literal that needs to be translated, you just prepend it or embed it in a tr function. And compared to what we have seen so far, this is very elegant. The default translation is in fact the key for the lookup. And if a translation is incomplete or even non-existent, then the string literal that is in the code is the string that is presented to the user. It is very concise and expressive at the same time, and very programmer-friendly. Format strings follow naturally from the functionality of the Qt string class. Strings with different meanings, but the same key or contents, they might need to be translated differently in other languages, and so you can differentiate them with a context. So the thing to remember is which parameter is actually the string and what is the context. But okay. Then plural forms are supported by supplying a counter as a second optional parameter. And in this case, we didn't need a context, so you had to supply an empty string, which is a bit meh. Because actually, it's more often that you need a plural string without context than one with. So this is a common side. But nevertheless, all in all, the Qt offering does tick all the boxes in my eyes in terms of capabilities, legibility, and maintainability. As we'll discover, the Qt developers have read a few pages of the gettext book. And the only thing is, you need Qt, which is not easily paired with D, sadly, not the least because they use an additional preprocessor of their own. In any case, you wouldn't want to need to pull in all of Qt if you just need internationalization. A solution that is framework agnostic and platform agnostic is preferable. So enter gettext. Oh yeah, one last thing. You can pass comments to the translator, which is very nice. And the syntax is that you use an ordinary C++ comment with a special tag in it. There, gettext then. This is the Wikipedia page. Its initial release was in 1990, 33 years ago. Initially, it was targeted at Unix-like platforms and the C language. After GNU came up with its implementation in 1995, it was eventually made multi-platform and also supporting many languages. So clearly, GetX has had a long time to grow and become widely used, which has led to the emergence of some kind of an ecosystem. What do I mean by that? The ecosystem consists of the GNU GetX system on the one side and third parties on the other side. Among the GNU GetX command utilities, you have a scanner for string extraction, a tool for initialization of a table for a new language, which sets some default settings, typically for that language. And you have tools for merging of existing tables, updating tables with changes that happened in the code. And you have a utility for converting a text form of the table into a binary form that's used for distribution. And there's several other utilities. Then you have the runtime part of the system. It takes care of string lookups in those tables, and also for a selection of the right language. And then you have third-party tools. You have your editors with their modes and plugins and extensions that do syntax highlighting for your text-based translation tables, if you want to use that. There are even dedicated editors that are very user-friendly. One example of which we'll see a screenshot later. You can just fire it up, load a translation template, select the language that you're going to translate to, and then you just see the source strings and what should be the target strings. And if you pay for a subscription, you can even use AI translation services that do most of the work, and you just have to review it. And it also sets the correct plural forms for different languages, because many languages don't have just two plural forms, singular and plural. And yeah, those are the translation APIs. And then we have partners. There are professional translation services that just know how to deal with a GetX format. And so that can be very helpful. And a very important principle of GetX is that software development is decoupled from translation efforts. And with the third-party editors, the translator experience is good enough that even an enthusiastic customer can contribute to the translation. As we'll see shortly, my DGetX package takes care of string extraction and the runtime. And for the rest, it ties into this existing ecosystem. But before looking at the D situation, let's briefly look at how GNU GetX is used in C, the way it was designed to be used. Because maybe we can give D programmers a better experience than C programmers. So here we have C. I'm using bold for the bits that regard internationalization to highlight the signal-to-noise ratio. And the features of GetX are that, as with Qt, the original English text is the key for the lookup in the translation table. So the programmer intent is clear. And if the lookup fails or no table has been loaded, the original English text is used, and multiple identical strings are translated only once. There. comments can be used to translators, passed to translators by special syntax, like with Qt, and these apply to the marked string that immediately follows the comment. If you use identical strings with different meanings, again, you can define the context, but you have to use a different function, pgetx. I don't know what the P stands for, but this is how it is. And plural forms are handled by yet another function, ngettext. And sadly, you have to repeat the number that defines the plurality, here n, once for the getText function and once for printf. And since translation is a runtime event, when you have constants involved, there are some hoops to jump through. These are actually the strings that you want translated, so the scanner needs to somehow discover them. So you have to define a macro that does nothing but helps the scanner, because you can't translate it at compile time, so you can't use it for initialization of constants. And then, I don't know if you can see this, but then you have to call getText functions on something that is not a string literal. So it's a bit confusing and cumbersome. Both getText and Qt take the right approach with the translatable strings being keys for the lookup. And Qt has been able to improve a little on the syntax compared to getText. But GNU getText has the advantage that it is self-contained and independent, which makes it excellent as a choice for the foundation of a D implementation, in my opinion. So on to the D experience. You get the package from the DUB registry at this URL. And as you see here, it features concise translation markers. You just prepend tr-bang to the string literal. And I chose tr-bang because, or tr, because I think the original getText keyword is too long. Even the GNU manual acknowledges this, and what they suggest is that you define a macro underscore to mean getText. But I don't want to lay claim on underscore in the global namespace, and besides, there's no hint that it regards to internationalization. So tr is the better choice, I think, because it hints at translate. And I like that there are no additional braces, parentheses. It's one character less than the C option. But if you want the GNU style, you can do this. And there's no other changes, configurations that need to be made to the scanner or something to make this work. I have a question. How many ways are there in D-Lang to write down a string literal? There are 9. Yeah, 9. There are 9 different ways, and all of them are supported. Here are some of them. This is an ordinary double-quoted string, which may have escape codes. We have WYSIWYG strings that don't need escaping of special characters. This is another WYSIWYG string, less popular, but nevertheless, it's there. This is one of 5 forms of delimited strings, and you can choose your own delimiters even. And I can't imagine why anyone would want to translate source code into another natural language, but it comes at no additional cost. So here it is as an example. If at any point D should introduce yet another string syntax, I wouldn't be surprised if this package just would support it without an additional change. The reason of which I'll come back to later. So, plural forms. Support for correct plural forms is a central feature of getText. And without support for plural forms, one would possibly use a formatted write line with an ambiguous form and let the user autocorrect while reading. Here, %d is a placeholder in which the value of n is substituted per write line. Or if you wanted to be grammatically correct in English, you could do something like this. The difficulty with plurality is that many languages have more than 2 plural forms, and that each language has its own rules for what is the correct way. And getText solves this. Using this package, what you do is that you supply the English singular and plural forms as the first and second compile time argument to TR, and the number as a runtime argument. Here getText will substitute %d with n, so the translated string has no placeholders. Hence the write-f line can be changed into a write line. And note that the variable n is only supplied once in contrast to the GNU getText implementation. getText will select the correct plural form depending on n for the currently selected language. Supplying these individual forms is the task of the translator, and it's completely separate from development. So this is taken care of by the ecosystem, and the programmer doesn't need to worry about it. So we are coming from Pascal, and Pascal does not support format strings, at least not the version that we were using. So many of our strings are compound strings that consist of a concatenation of string literals and string variables like this. I took extra care to support this, and this works. But it is bad practice because translators will only see fragments of sentences, and they don't know in which order they are used in the user interface. So in order to enable translators to provide correct translations, programmers should strive to present them with complete sentences as much as possible using format strings. Here the %s is a placeholder for the value of player. The nice thing is that you can use plural forms in format strings or vice versa. Here n is an argument to tr, and player is an argument to write-of line. TR will substitute %d with the value of n, so write-of line will never see the %d placeholder. And you may ask at this point, how does TR know which of these 2 placeholders to replace? Well, it always picks the one with the highest order, so %d in this case. And what if we want to pick a different one? Well, luckily, format strings allow you to define an explicit order. Consider this somewhat contrived example. In this non-internationalized code, we iterate over hand and bush. So I is first 0 and then 1, and where is first hand and bush, then bush. Each iteration does a formatted write line, differentiated for plurality, where I+1 replaces %d, and where replaces %s. So if you execute this, you get 1 bird in the hand and then 2 birds in the bush. So here the first placeholder, %d, is what corresponds with the plurality. And we can internationalize this like so. Each iteration, we have the 2 compile time arguments to tr and its runtime argument, and where is the second argument to write-of line. The $1 and $2 that are inserted into the placeholders specify an explicit order. %2d is the placeholder of the highest order, so that is the one that TR will replace. Again, write-of line will never see the $2D placeholder, str will have filtered out the highest order of placeholder in the translation. And the fact that format strings support explicit ordering of placeholders is actually very important regarding internationalization, because sentences with multiple placeholders and arguments may require a different order in some languages. By using explicit orders in format specifiers, translators can reorder the arguments as required in their language. It's kind of the same as this room contains 75 attendants versus 75 attendants are in this room. Depending on the language, one version may be more natural than the other. And it doesn't matter if you as a programmer haven't ordered the arguments. The arguments only matter in the runtime execution of the format, so that the translator can introduce order if needed. There are a lot of things you can do with format strings. It is a mini language with its own grammar, inherited from C. It is not the most accessible language I know, but it is fairly well documented on the format page of the dstandard library. Next up are comments to translators. Comments to translators can be passed as an optional parameter by wrapping them in the comment struct. I think this is nicer than the approach taken by GNU-GetText and Qt that use specially formatted code comments, because in this case, you don't risk accidentally detaching the comment from the string that it applies to. And by the way, translating proper names is not a bad idea. When translated to Japanese, for example, the translator will want to approximate the pronunciation of the name in a katakana script. And by using the International Phonetic Alphabet in the comment, the correct pronunciation can be communicated to the translator. Differentiating by context follows the same principle. Here we have two identical source strings that may need individual translation. And in the second case, we pass more information to the translator to make sure we get correct translations, so it can be combined. Actually, in this example, I could have omitted the context document in the first one, because if one string has a context and the other one doesn't, it is enough to differentiate the translations. And of course, plural forms also support comments and context. I think the approach with wrapping structs is very neat. It sets those arguments apart from the context strings, otherwise they will be strings, so you wouldn't know what they mean. So it's not surprising that so we can also avoid awkward null arguments like the Qt approach. So translation is a runtime thing, or at least we have chosen it to be. So it's not surprising that runtime variables can take the value of translated strings. Here are some examples that may surprise you. We have compile time constants. We have enum members. And enums only exist during compilation, right? And static initializers. I'm not saying that this is good form. My point is that this is working code. And it works because we let the type be inferred. If you require the type to be string, you get a compile time error. But if you leave that out, it just works. I don't think there is any other programming language where you get this. And the nice thing about this just working is that this requires very little cognitive overhead of the programmer. The internationalized code looks almost identical to non-internationalized code. But it's not just nice. In my job as a transpiler operator, it is very important. Since we previously came from translating source code before compilation, translatable constants are not at all uncommon. So we don't need many manual rewrites, it just works. At this time, it's probably nice to review an example that we've seen before. This is the hoops that C folks have to jump through. You have to define markers that seemingly do nothing, mark different string literals in different ways, and marks things that aren't string literals. It is very convoluted, laborious, and confusing. In D, you just mark your string literals, and you're done. The rest is pure programming logic. The signal-to-noise ratio is very high. And that's all API-wise. I think the level of comfort of this API is in line with what we are used to in D, and I like it. One more thing. Here's a string mixin. The tr-bang marker is embedded into another string, which could even be the result of compile time function evaluation. This is not a problem for this package. Now that we've seen the intricacies of the API, or rather the lack of intricacies, I'll walk you through the process of internationalizing a dub project. So I'm going to start with a project that you get after invocation of dub init. You have your D code at the file, source file at the top, and your dub.json underneath. And if you issue dub run, you get this, which prints edit source app D to start your project. So first step is to mark the strings that you want translated. Here in bold, tr-bang. And you add a dependency in dub.json to the gettext package. That you import in the source file, of course. If you run it, the program works just as before. It displays the string literal, even though no translations exist yet. And as long as you just want to be ready for internationalization, this is all you need to do. Or if you work in a team and dealing with actual translations is not your responsibility, there's nothing else to do either. But when the time comes to actually generate translation tables, this is what comes next. First step is to install the GNU gettext utilities. And by the way, the only downloads that you need on your dev machine only. None of this needs to be deployed. For Windows, there are precompiled binaries. For Mac, you have Mac ports and the like. For Linux, you obviously use your package manager. Second step is to paste this blob of text in dub.json. You most probably can leave this unchanged, but we'll briefly explain what it does. It inserts a bunch of configurations. The first one is just empty, which means that if you don't specify a configuration, it does nothing special. Then we have a configuration abbreviated internationalization. The 18 there replaces the 18 characters in the word internationalization. And the thing is that it adds a few pre-generated commands. So these are commands that are always executed. It instead, it runs another configuration. It actually executes that compile also. And the config is named xgettext after the utility that it replaces. And it's going to extract the strings from your sources. After that's done, you get merge. That's a sub-package of the gettext package, which calls the GNU gettext utilities for updating your translations with changes in the code. And then po2mo converts the text file tables to binary files, which are then copied into your target directory. And on the bottom, this is the xgettext configuration. And it hides the result of that compilation in a different target path. It switches on a specialized version, and it also switches on a specialized version in the gettext package. Second step is to, third step is to invoke dub build -- config equals internationalization. And this generates the pod file, and it's a template file. And since there are no translation tables yet, there are some warnings. I'll speed up a little bit. Maybe we can skip a few bits of this. What happens here? The invocation of message init, which is a tool. You initialize a table for a new language, Dutch in this case. It looks almost the same as the language field has been filled in, as well as the rule for plural forms has been added. So, and here you fill in the actual translation, and by invoking the same run with the internationalization configuration, it now generates the translation tables. So now we have both a PO and a MO file in the products for each translation. The only thing left to do is add some logic to our program to select a language, and now an ordinary dub run lets me enjoy my program in my native language. So this is a quick screenshot of the PO-edit editor that I was referencing. And this is an example of a language that has 3 plural forms. To conclude a little bit about the ideas on which the implementation of this package is founded. And this is primarily a testament to our forums and the community that we have. This is a post by HSTL from about 3.5 years ago. And I was actually going to read this out, but maybe you just scan the QR code. But it's a very nice idea that he had, and it works like this. His proof of concept stretches over several short files. The most important one is looking like this. And this covers the string extraction. String lookup is ignored. So when version extract string is on, we see that there is a global dictionary defined, and the main function that writes out the contents of that library, of that dictionary. Secondly, there's a template taking a string argument, and which version when version extract string is on, a module constructor is injected that inserts the string into the dictionary. For the rest, there is a function with the same name, making this an eponymous template, which returns the same string or its translation. The other files are just examples, of course, to the template function to demonstrate how all marked strings in all the sources are discovered. And you can see that the ordinary main function is ignored in the extract string version. And executing this in the extract string version prints out the stub for another dictionary. Here it is. That can be filled out to form a translation table. I had bookmarked this as a wonderful idea, and in the replies to this post, you'll see that he wasn't the first one either to have it. But since then, I had not yet seen this built out to cover the full feature set of GNU gettext. When I decided that it would be me to try and do this, I found a dub package, mo file, that reads the binary gettext format. So that came in very handy, and all was merry. Until I realized that for every translatable string, this instantiates a template function, string gettext. When we have a ton of these strings and bloating our executables just to get internationalization working, and only because we have a cool way to scan for strings, that didn't sit well with me. And so I returned back to the forums with a cry for help. And this time, Steven Zweighover was quick to reply saying, "Let me dust off my wand." And the nice thing of this is that the internationalized string does not have a bigger footprint than an ordinary string. What happens is that the template, when you run without extra versions, it just reduces to an idiom that instantiates a struct that wraps a string. So nothing more than a string remains after instantiation, which is the same footprint as that you had before. So this got me excited again, and this discussion went on with a few more equally valuable iterations, which you can see under the QR code. And the end result that I demonstrated earlier is a little bit more involved than these short snippets. Totally, maybe 800 lines of code. But those are the core nuggets that made this little project a success, which I think it is. So, quick conclusions. D now has an internationalization solution that is best in class, to the best of my knowledge. It is minimally invasive. The internationalization details do not obfuscate the code that really matters. And should I press this? Oh, do you want to press it? Functionality is practically on par with GNU getText. It is easily integrated in dub configuration, and translation efforts are supported by the GNU ecosystem. So it's just to use the package and report any issues. Thank you.
All right. It is question time, so start thinking of some.
Firstly, I want to say this is fantastic work. Translation is like a serious problem in a lot of different languages, and it's especially tricky because everyone thinks they know how to solve it, and so developers often immediately go and run off implementing their own solutions, and they don't know that there's languages that it's based on sound, not numbers. So 21, 31, and 41 all have the same ending, for example. So that's it's a classic one. So my question is, I've noticed everything was based on compile time strings, but like in a web server, for example, the locale arrives via a header. So what options exist for a runtime configuration and lookup the language? And also for the compile time, I didn't see in the examples, how do you actually select the locale?
Oh, yeah. I think jumped over that. I have a few functions that just inspect your installation and discover MO files and returns that in a slice. And then you select one of those. And runtime, the header, you don't know the header's existence before compilation? I know 5D uses a similar approach, and I'm not sure if, but 5D generates mostly static, the templates are mostly static, right?
So often the same service will have users from all across the world.
Yeah.
And each one at runtime can configure the locale, or even change, the same user can change their locale.
Yeah, so that's what you mean with the header. Yeah, it's session dependent.
Yeah, it's session dependent.
No, I think that will work. You just have to switch languages more often. So you have to look up the string. You shouldn't cache it between sessions. Should work, I think. Because the only thing that is compile time is the original string, the English string, which is used for a key. And the key doesn't change in between languages.
Dankjewel voor deze presentatie, Bastiaan. I wonder, there are many languages. You showed the example of having a flexible way for plurals, but like was already mentioned, there are many language features Like the English just has one article. The other languages have like the, does, they, and there. So does getText provide more like complex things that you didn't show, or are translators on their own to creatively solve language problems?
Yeah, I don't believe it offers much more features that support that. But the most important thing is to pass as complete sentences as possible to the translator. And then it's the translator's job to use the correct grammar. Do you think that will work?
Yes.
All right, let's do one more question. Come on, one more.
Luckily, I don't need internationalization in my tools. It's all English, but pluralization is always an issue.
What is an issue?
Pluralization, like
plural. Okay.
Yeah. So I started a solution by myself. I like the idea that the single form and the multiple form are provided twice, but it also feels a little dirty because they are mostly the same string. I was wondering whether getting a little too complicated, describing, with a domain-specific language, basically, they're describing this noun depends on that parameter argument, plural form, and put this way plural or not. So I was experimenting with it, but it got also complicated on its own. Just wanted to comment.
Yeah, on the messy aspect, you could, for example, decide to just, in one example, I used singular parentheses as parentheses. But that means that you always have to use a translation table also if you just want English to be displayed plurally correct. So you don't have a runtime fallback that is as feature correct as, yeah.
So I think a different solution, maybe a simpler solution only for pluralization, is still needed for English, at least, because of the lingua franca.
Yeah.
Yeah, I actually have a comment to add to that because we use translation services all the time in the video games industry, and they just want simple strings to translate. So there's economies of scale that you need to take into account there instead of trying to be clever about it. So,
yeah.
Vijay has a quick comment. We could do that.
I just wanted to keep it quick. One thing people may not realize is that by following a standard format, these PO files, there's online tools for people to use, like PO Editor, and that means you can hire external companies. They'll do all the work. They know all the tools. They can give you the data. Everything becomes much simpler when you have a standard format like this. So this is a massive addition to the D language.
Yeah. Before you wrap up, I have one additional comment. Yeah. So just in case anyone was going to ask this, I'll ask it myself. So the question is, why not just use libdparse? And I know the answer to this because I wrote, there's another subpackage which uses libdparse to discover untranslated strings, because you might want to look, am I complete? Where are the strings that I have overlooked? And it uses libdparse. But the nice thing of this approach is, the problem with the libdparse approach is that when the D grammar is going to change, libdparse needs to be updated, even if it's not string related. And then you have to recompile this package. And now this is just maintenance-free software.
Would you consider using DMD as a library?
Yeah, well, that's nice, but still you have to recompile because you have to use the new DMD library, which has the new grammar. This is just built in. There's nothing. It adapts. Even if you go compile with a DMD version that's 10 years old, or then 10 years in the future, it'll just work.
All right, let's wrap it up there. Thank you.
Thank you.
And we've got one more talk before the lunch break, so I think we can afford a 10-minute break. So go have a 10-minute break. Okay, that's your 10 minutes. Get back up here. Except for those that are already up here. Well, you can sit down if you're already up here. Actually, you know what? Why don't you just stand the entire talk? It'll be fun, right? Get a bit of exercise into your legs. Hey, John knows what's going on. Check him out. He was doing a better performance about 5 seconds ago, and then he stopped. Thanks, John. All right, so this is our last talk before lunch, as mentioned, and we have a first-time DConf speaker. And Vlad here is going to tell us all about the Quick protocol in the D language, so take it away.
Hi, my name is Vlad, and I will talk about my progress in bringing Quick to the D environment. The first question is, what is Quick? It is a network protocol that seeks to replace the TCP. The official RFC was published in 2021. Right now, it is used by about 7% of the old websites, and it's supported by the most popular web browsers. The question is, why would someone consider switching from a protocol like TCP to Quick? The most important aspect is the fact that Quick is implemented in the user space. Other protocols like TCP are implemented in the kernel space as a driver. One advantage of this different structure is the fact that it's simpler to update. If you want to change something to that protocol, you have to do that change only at the ends, the communicating peers. We don't have to care about the middle boxes. We do not have to care about operating system life cycles. And for those middle boxes, the devices along the path, that Quick transmission is just a simple UDP communication. And because everything is encrypted, including the header, they cannot tamper with that communication. And another advantage is, of course, you can leverage the use of D features like fibers and exceptions. Another advantage over TCP is the fact that we can multiplex our streams. In the traditional architecture like TCP and HTTP2, the multiplexing was implemented in HTTP2. Now every application can benefit from this feature. While I was working on this project, I read about a design pattern for network protocols called IO-free design pattern. What does it mean? It means that for me as a developer, I don't have to care about how the data comes to me. I give the user the options to choose a concurrency model, to choose what kind of sockets does he want to use. And what the advantage of using such a method is it's simpler. We can reuse this library. Every user has the choice to use what kind of concurrency model he wants. It is easier to test. We can create basically a quick communication offline, and we can interact with this through unit tests. And it is more modular. It's decoupled from the real network. This kind of pattern requires you to implement four main functions. The connect function, that function provides the initial key generation. It generates the handshakes that you will have to send on the network and so on. Another one is to parse the incoming datagrams. Um, what does this do? By parsing them, we can discover what the other peer communicates to us. We can end the handshake. We can add data to our streams. And we can send notifications. The provide datagrams function is basically the opposite. If you have any data on the streams, Quick will send it on the network. And of course, we want to close the connection. One problem that I encountered while working on this project was the framing. One another difference between TCP and Quick is that the fact that the cryptography data, it's embedded into Quick packets. In TCP, the initial handshake was something separate from the actual TCP transmission. And now, the current structure is like this. We have an UDP datagram at the top. This datagram can have one or more Quick packets. In each packet, we can have one or more Quick frames. In some Quick frames, we can have one or more TLS frames. And in each TLS frame, we can have one or more TLS extensions. So it kind of gets complicated. And the other problem is that each kind of frame has different rules of encoding and decoding. Some require you to put the length at the beginning. Some require you to put the ID at the beginning and the length later. And each frame has a different way of encoding that length. Some require a fixed number of bytes to encode the length. Some other require a new data type of var int that to encode that, especially in Quick frames, to encode that the length of the incoming frame. Here we have some code, and with some attributes, I managed to work with some user-defined attributes that let me tag each field according to the rules provided by the RFC. We have fields where the length is provided with 2 bytes, with 1 byte, with other that have that variant length, and so on. And also I had to add such an attribute to the frame itself to know if the length of the frame itself should be first, the ID, and so on. The problem is that each kind of, especially the difference between Quick and TLS frames, have different rules. When I want another part of the library to read such a struct after I got it on the network, I used an op-dispatch operator that basically, at compile time, goes over my fields and generates the required code as guided by my attributes. I have done a similar thing with the writing part. It's basically the mirror of reading. It iterates over each field in my struct. When I want to, I populate my struct with data, and with that get bytes function, I can convert my structs into plain bytes. Other things that I should mention is the cryptod module, in which I used the OpenSSL bindings. One task that I should do is create some interfaces, because now this cryptography module, it's hard linked to OpenSSL. We cannot use another library if you want. In this module, I implemented the header protection that allows us to that protects us from middle box tampering. The middle boxes cannot discover what we are trying to transmit. If it's a handshake, we have streams and so on. I can generate the key according to the new TLS 1.3 standard. I can verify my certificates, because this new standard allows you to have both ephemeral keys that change at every step, and you can also have to sign this communications using your permanent key, and you have to, in this way, you certify. I also worked a bit on a quick stream module. As I've said earlier, Quick is able to and should guarantee in-order data communication, multiplexing. Now I managed to do a bidirectional stream. One peer that sends those data can signals that it ended its connection and this transmission, and you can change the direction towards receiving. On this part, I have to do more testing. It is not yet properly tested. Well, that was my talk. If you have any questions, I would like to hear them.
Questions?
Question. So when you implement a protocol like this, is there like some test suites that you can use to check conformance? Because I guess there are lots of people writing the same thing in different languages. Is there some standard test suite that you can run your programming, your library against to see that it conforms with a quick protocol, or do you have to write that from scratch?
The thing is that the standard provides yourself with things that are compulsory to implement and other things that are not compulsory to implement. What it enforces you is the way to communicate with the other peer. The performance is up to you and up to each implementation.
Okay, but as part of the RFC, there isn't like some binary that you get that you can sort of test against?
Yes, indeed. There are examples that you can use to test, for example, the crypto module. And I used such test in unit test in my library.
Thank you.
More questions?
What is the state of current implementations in the browsers, especially with regards to performance compared to TCP? Is this a great thing?
It is better than TCP, but there's another protocol, TCP/LS, which basically does the same thing. It moves the protocol logic out into a user space and also improves the cryptography part. And indeed, because TCP is a more mature protocol, it managed to beat Quick.
Only in the new one you just mentioned?
Yes,
or, okay,
TCP/LS.
Yeah.
Come on, let's do at least one more question. Yes, right down here.
Hello, thanks for the talk. This might be way off, but I'm just curious. You're talking about cryptography. How resistant is this protocol to quantum? Is it post-quantum safe? I know
No,
this
it
might
isn't. It isn't yet. It should use, as far as I have read, you should use some lattice-based algorithms, which are not yet enforced by the standard.
So what do I have to do to use this in Vibe right now? Like in Vibe D, if I want to use it there.
Yeah, you can use it because it does not depend on, and this was a requirement of the project, it should be a standalone library.
Okay, so like what things do I then have to technically do right now to say my Vibe project now also should support this protocol because TCP is way too slow and I want to have it faster?
It is not yet fully, it is in progress. But after I will hopefully get to a more mature implementation, you should use, for example, the stream part. You can initialize a session and you can send your, using that stream functions, you can be replaced basically. It, for someone like a Vibe developer, there's no difference between using TCP and QUIC.
I have a question about the advantages of the QUIC protocol in the context of a person who's already using HTTP2, because there's a lot of similarity in concepts of like frames that can be interleaved and multiple parallel streams that are kind of multiplexed together. What are the primary advantages to a person who is already using HTTP2 of using QUIC versus TCP?
The advantage would be for a person that does not want to use HTTP2, and a person that would want to build its own application. QUIC does guarantee you stream multiplexing and in-order data transmission.
Any more questions? Oh, it looks like we're good here. Okay, well, thank you for your talk.
Thank you.
All right, so it is now, in fact, lunchtime. Everybody back here at 1:30 for the next round of talks, 13:30 for your Europeans with your 24-hour clocks. I have taken the black, so again, I will be guarding this room with my big presence. So I know some of you are going to pack up your laptops, but needless to say, there are people keeping an eye on the room at the moment, so you can relax a little bit, but up to you, up to you. Otherwise, enjoy your food. Hello, hello. If you've got a lightning talk, please come down to the front. If you do not, please enjoy the next few minutes. Keep playing the music, guys. Thank you. Welcome back from lunch, everybody. You are all back, right? Well, I can see Walter. That's a good sign. How was lunch? Woo! Woo! Excellent. Still a bit of the hangover energy, but that's fine. That's fine. We have something that'll wake you right up. Lightning talks. We have 9 speakers plus friends here ready to give talks. And the format is 5 minutes and you're off. We'll let everybody have a question or two after the talks and then straight into the next talk. And just to let everybody know their talk is finished, look at what I pulled out again. Yeah. Okay. So let's kick this puppy off. Murilo has the first talk, and your time starts now.
Hi, everybody. Is everybody hearing me? Okay. So my lightning talk, I'm just going to talk a little bit about how I entered this world of D-Lang. It was in the year of 2018. I had spent years studying C and Python very deeply, and I was bored. I thought, I'm going to look for some exotic language. And I had heard years ago from some guy at university about D-Lang. I thought, well, that sounds strange. Let me just check it out. And I decided to learn it just for fun, just to relax. And I thought, well, you know what? This language turns out to be actually quite useful because it is very powerful and it is very easy to use. And I decided to make it my main language, and as a result, nowadays I have been doing everything in D, and I even started going to some events there in my country, in which I would try to make some advertisement. I would often tell people about it, and I decided to go online on Facebook to search for some Facebook about this language because the Python Facebook group has, I think, 30,000 people. The C Facebook group has, I think, 40,000 people. And I only found one Facebook group about the D-Lang, and it only had 1 member. So I decided to, no, it wasn't me. The only member was the guy who had created it. And I ended up chatting with this guy, and he said, people left D-Lang when it changed to D2. People liked the D1 when it changed to D2. People disliked it, and they moved on to Rust. And I said, I'm going to create my own group, and I created my own. Nowadays, it has, I think, around 600 members. And I did it in an effort to see if I could maybe the language, make this language more popular. And I started making my own events there in my country. I started organizing my own events in which people would be able to give some lightning talks like this. In one of them, I was talking about computational art using algorithms. And here are some examples that I showed there. They were written purely in D, using the ARSD library here. This is the Sierpinski gasket algorithm, which uses recursion. It's gonna take around 20 seconds to finish the drawing, but in the end it looks very cool, and it's actually quite simple. And I have here the Sierpinski triangle, which does something similar, but with a triangle instead of a square. I'm gonna put here one beside the other, so people can see them in action. I use that as an example of how you can use computers to make art, to show that computer science can be something beautiful as well. And both of these softwares were written purely in D, using a library which was also written totally in D. The triangle is done, and the square should take a little longer, but you can see this beautiful artwork made here, in which it basically divides the triangle in 3, and then in each smaller triangle it performs the same division, and then it does it again in each of the smaller ones until it reaches a point, the base case in which instead of dividing, it just paints the whole triangle and stops. And what you have is this image, which, although very simple, is also very cool. And as you can see here with this square, I think you already get the idea of
30
what is going to
seconds.
happen in the end. How many?
25 now.
25 seconds. Okay. And I went to an event which was about free software, and I was going to give a talk teaching people how to make a 2D game, a simple game, and I made it all in D in front of them, and some of them were even interested and asked me if it was possible to become a developer in D, and I said, yes, you can.
All right, unplug your laptop from the HDMI and we will take 1 or 2 questions.
Which country? Sorry. Which country are you from?
Brazil.
Right, thank you.
Is it true you are one of the few people teaching D professionally as a private tutor?
I am a teacher, but so far I have only taught Python and C. I've never had a student who wanted to learn D. I usually mention the D language to my students, but they say that's not what my professor at university wants me to use, so they usually are not interested, but I try.
So people should contact you.
All right, thank you, Murilo. Next, we have Balut, and we're still getting set up a bit. All right. What did you think of that talk? Good? Good. Hey. Yeah, that was actually a first-time DConf speaker as well, and guess what? So is Balut.
Yeah. So my name is Bolu, and this is my first DConf and
it
also
starts
first
now.
ever lightning talk. So thanks for the opportunity. I'll just say that the title of the talk sort of works better if you use the British spelling of fiber, because then you have like fiber recursion. Well, so yeah. Yeah, I love recursion because you can really like express many problems naturally with recursion. So for instance, say we have a toy language. It's basically brackets around some integer, and we want to parse that. Well, naturally you can express this as a recursive algorithm. So we have like a top level parse that takes some string, really just calls like parse expression. Parse expression basically would figure out whether we're in a group, so with a bracket, and call parse bracket or call parse number. Parse number is like a leaf, whereas parse bracket recurses into parse expression. So this is simple enough and quite natural to write. So yeah, we have also like this util, nested value, which tells us the depth. So we can construct strings with whatever level of nesting. So yeah, that's all fine. We run it, we get 5 or 10, what we really expect. But we make a small change, and we try to create like a nesting value 10 to the 6. And what happens? Well, it seg faults, right? Like naturally. Yeah, so you remember Dennis's talk from Tuesday? He talked about like, the stack and how awesome it is, but it has this limitation where you have like a stack size limit on most systems. So it's either 1 MB or 8 MB or something like this. So we could either like convert to iteration or emulate recursion, right? And guess what I did? Yeah, so yeah, manage recursion. This goes against what you heard yesterday from Walter. Don't reinvent basic features of the language. Well, too late. Yeah, so yeah, we have like this plain call util, which we are going to use to reinvent recursion. So we defined 2 functions, run and call. And anywhere we sort of made like a recursive call, now we just use our call util to make that. And at the top level, we run this thing, right? So, I mean, now we still expect that, it's seg faults because we've not really done anything. But what do we actually need to do, right? We now have an API, and let's implement it. Well, to like make a recursive call, you need to be able to like suspend execution at some point, do something and resume execution, right? That's what you do when you sort of recurse, and that's really sounded like fibers to me, right? Like so yeah, let's make recursion out of fibers. So manage recursion via fibers. So here we have the fiber call util, and it's got a bunch of utilities, but the main part is same run and call. So for run, we've got like a call stack that is just like a bunch of fibers. And basically all we do is that we basically append to the call stack and, try to exhaust the call stack, running the fibers, checking their states, and either popping or running again. And we have, well, at the end, we try to read the results, right? So we read the return and return this. And same thing for call, we append, a new fiber created from functions to the call stack, and we basically yield, so suspend, and then we hope that when we come back, we sort of have some value. So yeah, that's basically the scheme, and yeah, now it works, right? So we have this, well, we take advantage of the heap basically, and so we don't have this problem anymore. Yeah, and that's pretty much it. So we get like an extra order of magnitude in recursion depth, but it actually kills my computer memory. I think what's happening here is that each time I create a new fiber, I get like a whole stack, but what I really need is just a stack frame, right? So I think I think maybe stackless fibers might be helpful, yeah, for this sort of abuse. But yeah, that's it. So what's the conclusion? Well, why would you even want to do this? Take Walter's advice, don't do this. It's a bad idea, too much overhead. It's probably better to just like compile with the right flag. So we should probably ask Dennis about that, or find a better algorithm, iteration, whatever. But it's really not about recursion. So basically, like the concept here is that you have like a kernel that runs your code, and you basically yield control to the kernel with some request. So basically, the kernel is smart enough, to do like the dirty jobs and give us the results. And that's what we basically exploit here to do recursion.
30 seconds.
Yeah, so yeah, and we see the similar concept, with Python generators and coroutines, and that's how async IO is implemented. Probably slightly better in Curio by David Beasley. And yeah, that's the end. I have examples, well, the code basically at this address if anybody wants to like try it out. Thank you very much. Questions, anybody?
Can I still do it? Can I still do it? All right, well, we got 1 second, and... All right, take your HDMI off, and let's take a question or two. Come on, you must have a question.
Yeah, can we bring the gong to all future DConfs?
Right.
It said, can we bring the gong to all future DConfs?
Yeah, you probably also found this segment fault in fibers, right? And when we first found it, was why is the segment faulting? Oh, it's because you haven't set the stack size, right?
So sorry, I didn't get that.
So you probably found the stack problem in the fiber stack problem, right? So because I think the default stack size is very small. So if you don't set it, then you get a segment fault.
So I don't set the, so no, it works fine. What I actually get is that if I increase the recursion depth, then I basically run out of computer memory. So that's a different kind of error because I have like all these fibers allocated. And that's why I'm thinking, okay, maybe some stackless fiber might work instead, where I don't get like a full stack that I don't really need because immediately I'm just calling into.
Yeah, I know. But we run into a problem that when you have some simple recursion inside a fiber, the default stack size is very small. So
yeah, so yeah, I don't recall.
Okay, yeah.
Thank you.
Oh, you're all prepared. Yeah, we're making up. All right, so next we have Luis here. And give me a second, I need to get back in my spot. All right, your 5 minutes until the gong starts about now.
So, hey, I'm Luis. I work at Weka, and I'm presenting LDC-Lint, which is a compiler plugin for post-semantic analysis. This came from an idea that I had to make a linter from the DMD as a library. So I created DMD-Lint, but it didn't go quite well because DMD as a library had a lot of issues. And thanks to Razvan that also made this a little better. So at Weka, we got this idea of running a post-semantic analysis plugin, so we don't need to run the semantics again. So basically, Joan started doing the plugin interface to implement plugins for the DMD AST. So I started implementing LSE-linked or porting DMD-linked to LSE-linked, some rules. I only have 3, I guess, or 4. But it's pretty much a proof of concept right now. But it should be simpler and run faster in terms of not running the linter into calls. And also you can specify the linter in the compiler arguments and put it in the default arguments of ldc.conf. So you don't need to just worry about it, just enable warnings and it works. So I can try to do a demo. This is not really prepared, but well. So I'm going to show you so I'm going to show you how I test the linter, and this is lit with file check. So this is rules that are running right now. This is very simple rules, and most of there's false positives right now that I'm trying to fix. But ultimately, I want to run this in a B code base. But the rules that I implemented is unused variables or unused symbols, and redundant segment expressions. And another idea that I had to implement is unused imports, but it's quite more difficult because I need to create a graph of dependencies, and DMD doesn't have enough query helpers for that. But I can show you this running, I guess. So this is a build of LSE-lint for Weka compiler because this is my work laptop, but it should work. So yeah, this runs with the warning and error interfaces from DMD. Soon I want to probably shift from that because there's some warnings. Currently, there's no way to disable compiler warnings or specific warnings.
30 seconds.
But you can also specify some arguments for the LSE-lint with environment variables right now. It's a bit clumsy, but so this basically disables all the rules, but you can enable another ones, like just unused.
All right, unplug your HDMI and let's take a couple of questions. Ali down the front.
Why does it say appears to be unused?
What?
The warning message said some function appears to be unused.
Well, yeah. I'm not very good in namings, but yeah, it's unused, but it should be unused. Yeah, thanks.
Let's go one more question. One more, come on.
How does this compare with DScanner?
Well, this is still really crap. So if you want to have proper linter, just use DScanner. But well, soon it will be less crappy.
But DScanner, I don't think it has unused variables.
Oh, okay, yeah. So cool. I think it have, but not for mixins and stuff. This is mostly like because we have we need semantic analysis, and this scanner doesn't do semantic analysis at all. So I think there's a fork for this scanner to use DMD as a library, but it's alpha baked, I think. But yeah, well, at least I have a purpose to do that, and I think Weka needs that. So maybe I'll go to implement that.
All right, and thank you, Luis. Next up, we have Robert, who's going to give us his best freestyle rap for the next 5 minutes.
Oh, please, no.
It's open mic night. Come on, let's do it. Your 5 minutes starts now.
Okay, so apparently I registered with Ethan to give a lightning talk. He just told me. I have no idea what happened. And I don't even drink, so let's see what happens. My list of features you shouldn't probably use wasn't exhaustive. And I mean, there's only so much time you have to talk about stuff. But obviously the other things you probably shouldn't use, which make your life difficult. Like the obvious ones are like GG shared. And then also I think immutable and const quite often make your life a lot harder than it actually needs to be. Like I'm not sure if you can actually get rid of it at some point, but immutable seems nice on the surface, but like the actual benefit of it is not that big. But like I guess most of you have experience with that to some degree, but then maybe what is like not that much or that obvious. So one of the things that I mentioned in my talk was using nullable to basically get a return value. But nullable is also quite old, and the interface is clunky and has some like really nice footguns in there. So you can check if it's null, but you don't have to. You can just call get. And then in that, it checks if it's null. And if it's not, an assert will throw unless you compile with release. But what most people don't know, there's actually a default parameter that you can pass in. So, and that, as far as I remember, is actually lazy, which is another thing that seemed very smart on the beginning. So for the people that are lucky that haven't used lazy before, you basically can say, this parameter is lazy. So there's actually a lazy keyword in there. And the idea there is that the expression is only evaluated when you actually need the value. But that gets really hairy if that lazy expression has side effects to the outside world. So it's basically a delegate that doesn't get called until it gets called, and you don't really know when it gets called. So lazy is probably a feature you should also really not be using. So what else? Another pet peeve of mine is trailing commas. Like Stephen, who's working with me, really hates me for it. What I like to do if the line gets too long, I put the comma at the beginning of the new line. Exactly. But you're all wrong. You're all wrong. Like it's it's the best thing ever. Because like especially if the next or the line after that is having an if and you start another level of indentation, it really doesn't really make sense to, or it's really difficult, at least for me, to see where it is. And then also, you not intend, like the indentation for the comma is actually 2 tabs. And a tab is obviously defined by the number of spaces, which is 4, but tabs are still better than spaces. See?
I like tabs, shut up.
That was actually the reaction I was looking for on Tuesday, but at least I'm getting it now. But actually, if you, for instance, take a look at the Elm language, their default is actually leading commas. And like in all honesty, take a look, especially if you're creating object literals or have really a bunch of parameters that you want to pass to a function. It's not as shit as you all think. Like really take a look. So what else do I not like? Can you please hit the gong? I'm running out of material here very quickly.
Come on, you got a minute and a half. Just freestyle, man.
Freestyle? You don't want me singing. Otherwise, like, the room would be empty at this point.
Come on, we don't have a deep rap yet. Why don't we just start?
for enough, so I'm just stopping and give like another minute to the next person then.
That's not how these work. Fine.
Any questions at this point?
All right, so we can have two people abuse Roberts for his opinions here. Let's hear it.
Any questions?
How did you get so wrong?
Remember when I started talking about like not remembering that I'm actually supposed to give a presentation and I'm not drinking? Please tell me, I don't know. Next thing to go is going to be my name.
All right, who else wants a turn at this? Let's hear it. Put your hands up. Come on. There we go.
If const is useless in your opinion, what about a function that wants to be pure and wants to take an array that it does not want to mutate?
So pure is interesting. There I sort of would go to what Attila said, like rule number 1, use your head. Like the thing I forgot to mention sort of earlier is like no throws, another, like eventually something's going to throw, just live with it. It's not perfect, but well, that's life, right?
So you mean that just needs for pure attribute?
Yeah. I mean, to pardon my French, but at some point you just have to shovel shit every once in a while.
All right, thank you for that enlightening talk, Robert. Guys, we do this once a year, so please sign up next year. It's going to be great. It's going to be great. Anyway, we've got some not just first-time DConf speakers, but first-time speakers.
Wow.
Wow. Come on, programmer energy. All right, so we have Alexandre and Gregoire, and they're going to talk about data exchange for 5 minutes, starting now.
Hi, I'm Gregoire from Ahrefs, and I'm going to give some introduction for Alexandre's talk. So Ahrefs is a company that is like basically doing big data. We sell data to people doing online marketing. So what we do is we have a backend team that runs a crawler and like crunch numbers, and a front end that is going to serve this data to users. All the backend is written in OCaml, and like if you ever look for a programming language, that's the best programming language around. We provide this data to our front end, and why did I jump like this? Okay, sorry. Few years ago, we decided to move our front end from all the mess that was like PHP and JavaScript to WYSON-ML. WYSON-ML is basically like a shiny syntax for OCaml. And one of the founding stones that allow us to do this is ATDGen. So ATDGen is a language in which you describe some type, and it's going to generate encoder for JSON as well as type definitions. This allows us now to have fully typed data from the backend to the front end. ATDGen also exists for Python or like Java. Well, now we are at DConf. Why am I telling you about this? So a few years ago, we started to build our own search engine. We already had the web index, so building a full-scale search engine was not that far. The core of this is in C++, and we have the layer above this in OCaml that is doing a lot of communication with C++ using JSON. It would have been very nice there to have ATDGen. Sadly, we didn't. And now we are moving this C++ code to D, and we decided to make it easier for ourselves by having ATDGen from the beginning. So now Alexandre is going to show you more about ATDGen itself.
Yes, thank you, Gregoire. So I'm one of the 2% of the company who actually does D. I'm going to show you exactly how that works. So in practice, you just define a type in this syntax, and then ATDGen will generate serializer and deserializer in various languages, D and OCaml, and that's useful for exchanging data. So in practice, that's how it works. So we have this type search query and two fields. That the first one is a float, a list of float, and the second one is an integer. And it's going to generate the corresponding destruct with one serializing function and one deserializing function. And the nice thing about D is that thanks to UFCS, you can just call it like that. And yes, I'm using vibed, I'm sorry. To do everything in one line, and it works well. It checks that the JSON you actually provided is correct. In addition to that, we also have a couple of cool features in ATD. So one of those features is type annotations. So if you're not happy with the default type that is actually being used, you can just specify the dealing type that you want to use for the representation, and it will use the correct type. Also have optionals, which underneath is using nullables. This allows to provide or not provide a value, which can be useful. And we also have some types. So the problem about D is that some types is not really first-party features of the language, while in OCaml it's a first-party feature. So that's how like some OCaml ATD code, which describe a type that can be of multiple different types, will be translated to D code. So for the moment that works, but I think it could be better. And we also have other cool features like templates. So you can generate templates, inheritance, and tuples. Even though tuples also kind of suck in D, but it's okay. So what to take away from this? Again, some type, I wish some type would be easier to use in dealing. If you don't like all of this, it's also convertible to JSON
30
schema.
seconds.
So, okay. And what's nice about it compared to Open API specification, like the talk we saw on Tuesday, is that it's lightweight. And you get to use OCaml, which is very fun. And it will open source soon, and thank you. Oh.
They're going to have my head if I don't hit it, so. All right, take your HDMI out. Let's take a couple of questions. Chris, you were up next. Yes, perfect. Question time, up the back there.
Yes, so one of the speakers clearly said that OCaml is the best programming language in the world. And I assume this also means that OCaml is better than D. And having seen Robert's comma-first, tab-filled source code, I can concur. But what is the motivation for D in this OCaml ecosystem?
We are so it's really the core of the engine itself, and it's quite low level compared to what we usually do in OCaml. So it's always a question of where you put the needles between like OCaml and like C++ or D, and I think we get something good here, but doing this like lower level manipulation in OCaml would actually be painful. Does that kind of reply to? I don't know.
And D is fun.
One more question. Let's have one. No? I don't think that, no. Really, guys? Come on. One more. Here we go. Hold on. Let us give you, for the streamers at home, all right?
It's okay. Which one is better, D or OCaml?
If you ask me, I will say D. If you ask him, he will say OCaml.
All right, I think we're done then. Give it up. All right, Chris, you're a first-time DConfer as well, aren't you?
Yeah, I think after 5 minutes of really woefully bad programming puns, I suspect it's also going to be my last. So
well,
I will.
Well, we did say it's open.
It would be nice having me.
We did say it's open mic night, so let's hear it. 5 minutes starting now.
Yeah, obviously feel free to show your appreciation with moaning, groaning, whining, sighing, and face palming on the table. And I assure you will. There's also a little bit of maths near the end, so but I'll wait for you. Don't worry, you'll be obvious. Okay. So recently I voted. So recently I visited the opticians after I started seeing keyboards, printers, and mice out the corner of my eye. She said, it's okay, it's just peripheral vision. That's good. You've got the level, that's good. I visited the doctor as well to see if he could help with my migraines. I thought it was very odd that he suggested I do programming to help, and then I realized he said codeine. Actually, my doctor would make a really dangerous C programmer because he thinks anything that's broken can be fixed with a cast. One of the features of C++ is that it comes with complexity guarantees. I mean, if you use C++, it's guaranteed to be complex, right? I've always thought of myself as a pragmatist. I mean, when my C++ code generates warnings, I just program them out. Whenever I see static used in multi-threaded C++ code, it makes my hair stand on end. I recently tried using D, but I suddenly found myself, as soon as I got to learning about the bottom type, I found it was the point of no return. Anybody else notice that Python 2.4 was a much nicer looking language? Was that when they brought the decorators in? Is a cross-functional team an angry bunch of Haskell programmers? I've given up playing poker with functional programmers. All they ever do is fold. When Sherlock Holmes talks about a three-pipe problem, does he mean one that has grep, cut, sort, and unique? When I'm working from home, I like to get my kids involved. I call it au-pair programming. I have worked at a company that did mob programming. They hired a bunch of gangsters with baseball bats to stand over us and make us do an 80-hour week. You can always tell when your Secret Santa present's been given to you by the enterprise architecture from the excessive amount of wrapping. If I join the database channel, the front-end channel, the back-end channel, and the infrastructure channel, does that make me a full Slack developer? Always make your version numbers palindromes, then they're automatically backwards compatible. If you think keeping up with the Kardashians is hard, you should try JavaScript frameworks. I think more people should get a career in topography. It's character building. Whenever I try and spell Octothorpe, I just make a hash of it. Have you ever wondered why some people are like the char type in C? They seem to get promoted for no apparent reason. My wife and I have been together for 25 years, so I thought I'd get her a token ring. Apparently you can only get Ethernet these days. Have you noticed how the McDonald's network cards all start FF, FF, FF? Because they're like a big MEC address. When they accepted their Turing Award, I recognised Diffie on the left and Hellman on the right, but who was the man in the middle? I bought the second edition of Martin Fowler's refactoring book. I recently bought the second edition of Martin Fowler's refactoring book, and I was really disappointed. The content was exactly the same, but the chapters were just in a different order. I've been thinking about writing a novel myself. It's a dystopian piece about a 16-year-old lad who's constantly fighting to prove he's not a robot on the internet. I'm calling it Capture in the Rye. Most of my systems have 5 nines reliability. Sometimes they work more than 45% of the time.
Thankfully, there's only 30 seconds left. Keep going, keep going.
The Wildlife Trust has deemed our code base a conservation error on account of the number of bugs. I gave up the other day trying to upload a picture of Marcel Marceau to a website. I just kept getting a 415 unsupported MIME type. You should never upgrade your database schema. The sequel's never as good as the original.
I'm going to enjoy this.
There'll be no questions.
Nah, come on, let's ask a question. Come back here, come back here. Come on, you need to take account for what you just did. Get back up here and take some questions.
Yes, sorry.
What is the favorite dish? Here.
Sorry, sorry, what?
What is the favorite dish of a functional programmer?
So the favorite?
Dish.
Oh, I don't know.
Lamb. Duh.
Oh.
Right, you as well, leave.
Was that more of a comment than a question?
Does anybody else have one? Come on, let's get this over with.
How many of these were generated using ChatGPT?
I don't know. All right. Oh, I mean, none of them. I mean, you know, they're sadly all my own work. I only have myself to blame. That's the worst part of it. So.
What did you take, and do you have some more?
I'm just compensating for the fact that there's an expression here. Those who can do, those who can't do, teach. And those of us who can't even teach, well, we just have to try and make up puns about everything else.
Fair enough.
Can I go now?
I don't know, do you guys...
You lot felt uncomfortable before, now I feel uncomfortable.
Yeah, good. Anybody else? Okay, Walter actually has a comment. Wait a second, please, Walter.
Well, I decided to grade your presentation, and I'll give you a D.
This community officially has no hope. Thank you, Chris. Aye. All right, well, Dennis is back to give us some quality content, please. All right, let's go. You got 5 minutes starting now.
Okay, so before the talk, I have plenty of time, I know. So there's a pull request here. You know how you can't assign a associative array to a global variable. I was asked about this at breakfast by some people. Steven made library code to convert it to a struct at compile time, and using that, it's easy to fix this long-standing bug. And I thought it would be fun to maybe merge it live. It's been open for a while. To approval, so these guys are complicit. Let's try it out in the next beta and send all your bugs on Bugzilla. And now, completely unrelated, the talk can finally start. Building DMD. So building anything in general. I have a low tolerance for complexity when building your open source project. I want to clone it, enter it, and then if it's good, just run one simple command, standard, and I get a default configuration, a working executable. And everything more complex gets downhill from here, like having to install dependencies, fair enough, and initializing submodules. Oh, I should have cloned recursive or something. And multi-step, multiple instructions with meta build systems. And worse is even when it's non-trivial and not documented, I have to scour the repository for the right makefile. Or worse is, please install this fancy, awesome build system, which you have never heard of. It's totally worth it, and meh. And there's even a special place in hell for these kind of things, where a litany of manual build steps of downloading, unzipping files, and then going through all kinds of hoops just to build your stupid project. So where does DMD fall on this scale? It used to be that you could just use make, but you did have to specify the make file for the target with the F flag, so not quite S tier. But worse than that, while on Linux you could use GNU make, on Windows you had to get the special digital Mars make from the DMC compiler, put it in your path, and make sure that that gets found before any GNU make, or else it wouldn't. Best make ever, says Walter. But it was not very contributor friendly, so it was changed to a script written in D. So anyone, decompilers have a decompiler, developers have a decompiler, so just use RDMD. But the build script itself is like more than 2,000 lines long, and it combines the implementation of a build system with the configuration to build DMD. So editing is quite hard, and it would output commands like this. So that makes it hard to like modify it. And I was like, why can't it just be DMD-I to compile imports, and then the main file? Like, all the source files are in the repository. There's no external LLVM dependency. Just pass the source files to the compiler. Well, DMD has a backend translated from C, which had some prototypes to access functions without imports. So those would be implicitly imported, but not built with the I flag. So in a series of pull request, I finally got rid of all of them, and so now proper imports are used. So now you don't have to list every source file. Another source of friction was version Mars, which was used because the backend is shared with the DMC C compiler, which is no longer maintained, so these can all just be enabled by default and removed. There are a few of these left in the front end, which can be default replaced by a check. If it's not in GDC or LDC, then it's in DMD. There are a few string imports which have to be specified with the -j flag in order for the compiler to find them for security reasons. Don't really agree with them always, but I haven't got rid of those yet. So currently, I've reduced the complexity of building DMD to first on Linux, you have to create a sysconfdir file which is specified where the configuration file gets placed. And then from the source folder, DMDI main with 2 string import flags and then an output file. DMD.exe, and this builds in a similar performance to the build script. There are a few differences, like DMDI alone doesn't include debug info, and the build script does some multi-threading and incremental builds. It builds separate parts. But yeah, DMDI works just great, and I've posted about this on the forum for some more details. And ideally, it's just dub build, and
30 seconds. 25 seconds.
Okay. So yeah, ideally it's just dub build. Now I've reduced, seen the minimum amount of effort required to build DMD, so that wouldn't be hard to add. So yeah, if I have some seconds left, I can just say use neat, the language from Matthias. He wants a user. And that's all.
All right, you guys want it, don't you? All right, unplug your heat. Yep, excellent. Now we'll take a couple of questions.
So I like dub, and you seem to like dub, and I'm curious, why is there so much drama about it?
Well, confession, I don't actually like dub. I like dub. Okay, so what I really like about dub is that most D projects, you clone the repo, you run dub build, and then you get a working executable. That's like what I want. What I don't like is the complexity of the specification. Like dub projects are just so simple, just a collection of source files, and still you have all these fields. So that's why working on it, the code base seems harder to approach than it should be. But yeah, what was your question again? And why they dislike it? Well, for more complex builds, which some people apparently love, judging by how those build steps, it's not very flexible if your project isn't just a collection of D files and has to have a complex dependency of other programs that need to be run before building your project. So it's simple, but it's simple by design, and some people like complex build. Yeah.
Cool. Do we have a quick question? Quick one. Nope. All right. No more questions then. Thank you, Dennis. And guess who's back?
Hello.
I didn't like the sound of that sigh. Do you have another rant to make?
Yeah, a little bit.
All right. You got 5 minutes. Go for it.
Right, I hate build systems, and yet here I am to talk about one. Why? Rage-induced development, because all of them suck. Build.d, by the way, is even worse. Now, to answer your question, why do we dislike dub? Because it's not a build system. It's a package manager, and it has a default build system that works really well if all you want to do is take all the D files in source, build them, please, and use the -i flag and make it available for other people, which is great until you try to do anything non-trivial, at which point it keels over and dies. For instance, if you want to build something that depends on your final binary, you can't. I mean, you can do a post-build command, but you can't make it depend on the fact that you just built this thing because it's not a build system. So you can't really add edges to the DAG. It's not possible to do it. And people have done a lot of workarounds around it, and it just doesn't work. So I built one called Reggae, and the name is obvious if you look at dub. And what it does is it's built from the ground up to be a internal DSL in D to build a DAG. So you can specify edges in the graph and what it should produce and what the command should be to produce it and make things depend on each other. And instead of using make, you use this. Now, built on top of that is basically a meta build system. So it's like CMake, but instead of their horrible language, you use D instead to describe the build, and then you can do anything. And the other thing I wanted to really do is the fact that Dub is ubiquitous is a good thing, so I agree with that. You don't need to know anything about anything. You can just add a dependency and off to the races you go. But Dub builds everything all at once by default, which is slow. It doesn't know about dependencies. If you change any module in source, then it will rebuild the whole thing again, and I don't like waiting. So let's not do that. So instead, Reggae asks Dub for the information about the build, including all of the transitive dependencies, and then generates a build. What I usually do is use the Ninja backend, but you can use a makefile. There's a binary one as well. And by default, it builds per D package, because that ends up being faster depending on the dependencies. Ask the compiler what the dependencies are, so you don't rebuild the whole thing. You only rebuild what you need to. And uses threads, so when you're building per package, it tends to be a lot faster. So you can get reductions I just tried vibe.d with Dub, and it took twice as long as Reggae, and that was from scratch, having to download all of the dependencies each single time. Because Dub does it sequentially, I don't know why. Reggae does it obviously in threads, because that's the only way to go, because we're not in 2003 anymore. And I have 32 threads, why am I using one? And yeah, use Reggae. I mean, if you just type Dub run Reggae instead of Dub build, you'll get a better build that will be faster, and you'll want to throw your computer against the wall fewer times. Is that just me? No? All right, okay. Rage. I guess I'm done there.
Well, apparently you're not done until I do this, so...
Questions?
Now you're done. Let's have some questions. When you use the DMD, for instance, dep make, it doesn't include the inner imports. So how do you do the dependency?
Doesn't do what imports?
Doesn't include the if you have an import in scope. So if you have an import, it only takes the imports which are global.
I've not seen any problems with this. I mean, we're using this every day in production, and I think.
Okay, so it works now, because we tried, but I don't see.
So MakeDeps had a bug in it, which I filed years ago, but somebody fixed it semi-recently, like months ago. And
okay.
Yeah.
Okay.
Before I was actually using DMD-V and parsing the output to do something. It was a mess.
Okay, maybe it works. Okay, thanks.
Any more questions? Yeah, we have a bit of setup issues, so please ask questions.
What are the biggest hurdles in D when it comes to incremental compilation?
When it comes to
incremental compilation of separate modules.
There's some template issues that have happened in the past with template emission bugs. There were a few bugs with unit tests that I fixed because there was a counter that was basically being used to name them, and it didn't get incremented the same way. But I mean, like I said, we're doing this every day at work, and it mostly works. Have we had problems? Yes, but it mostly just works. And in any case, I said Reggae does compilation per package by default. It doesn't need to. You can tell it to do per module or all at once.
That answers the question. Thank you.
I think John's got a question first, and then Stephen.
What is the justification for having a separate build tool and not just making the compiler able to do all this stuff?
Because it doesn't do it right now. I would rather the compiler be the build tool. I don't care. Rebuild things, please. Why are you making me care?
And if you did that, how would that interact with multi-language builds?
Good question. Sure. Also, another thing I failed to mention that Reggae knows how to build C and C++ files too, so you can just mix all of them. I mean, you can literally go, give me object files for that directory, and it can have C, C++, D. It'll just do it.
Yeah. So you mentioned there was 3 backends, right? You got
4 actually.
Oh, whatever. 4 backends. So Ninja is, I think, the default, right?
Yeah, it is now.
Okay. I think I've only ever used Reggae to build the Ninja thing. I didn't even know that had other cool backends. But what do you think is the fastest? Like why have the binary one? Is that
in case you don't want to depend on Ninja being installed on the system, so you have a D description, all you have is a D compiler, you have no external dependencies and their work, that would be the justification.
And which one do you think is the best, Ninja or?
Yeah, I just use Ninja at this point. There's also several front ends. You don't need to write the description in D. It can also be done in Lua, JavaScript, Ruby, and Python, because I'm insane.
Sounds good.
All right, we still having setup issues?
Well, also because compiling the D descriptions can be slow, and by slow I mean 2 seconds, which I don't want to wait, so there's that too. Because for the description to be in D, you actually have to compile that code to be able to run it, so. Yes. The question was, do I have a backend for TUP, which is a very not well-known build system, but again, I'm insane, so yes, I do.
Yeah, how critical is the display for your presentation?
Just
You
wing
just
it.
wing it? All right, cool. Thank you, Attila. Now, this is the stereotype here, Linux on a projector. Whoops, what happened there?
It's odd.
These guys are also first-time DConf speakers, so, you know, they're not having the best time right now. Give them a little bit of support. This is Philip and Lucas. You're going to have to do it screenless, and your time starts now.
Yeah. My name is Lucas, and this is Philip. We had 15 minutes to prepare this, so let's see how it goes. We work at DConf, and we started there about a year ago, and we just want to talk quickly about our experiences with that. So when we started, actually, our job wasn't to program D, but it was actually to make a testing framework for our main product in TypeScript, because we were told it was much easier than writing it in D. So spoiler, it wasn't easier. It was actually a lot harder. So after maybe a month, we rewrote everything in D, and yeah, that's what we worked with to begin with, and then we have worked on a couple of other things as well. Yeah.
And I think a fun thing to say as well is that it took some guys 4 months to do this TypeScript that we finished, but it took about a month to make it in D, so that's pretty good. Yeah, so we created a lot of cool stuff, and we also had some things we wanted to show you. But we have 2 main products that we have created, me and Lucas and the rest of the team. And one of them is a database. So we have created a system for creating a distributed database. And this database is basically a sparse Merkle tree with a width of 256. So it can store a lot of different data. It can store basically all hashes. And the smart thing about this is that we get one bullseye that we use for our consensus. I actually don't know, did we explain what we do? We are creating a new distributed system, basically. Yeah, but yeah, so we use this bullseye for getting the state of the database, basically. And this bullseye is very fast to calculate compared to other systems. Yeah. And it's a bit unfortunate that we can't show it, so instead we'll talk about something else. One fun thing is actually we have some different parts where we use all sorts of things from D, and we actually use Red Black Tree from Phobos. And one thing I really found awesome about the D community was when I had a question about it, I went to Discord, and in like 4 minutes, I had the question from Steven, who I think wrote it, and that's just like, what other communities can you just go and like instantly get an answer from the guy who made the library? I think that's really awesome. Yeah. Yeah, we also have created a hash graph, which is our consensus algorithm, and we had a really nice animation for you guys, but it's a really cool consensus system, and yeah. Yeah.
Too bad. Show it off at DConf.
Yeah. Yeah. Another thing is what I have mainly been working on is we have because we have our different nodes to be able to be distributed, so we can make consensus between it. And the node is architectured in a lot of different services in one program. So we use the concurrency library for it, and because we had some issues with it, we tried to make it more structured. So we built like a extra framework on top of it to make it type safe. But the problem is sometimes you get like when you have a list of messages you pass to the concurrency, you get like a million long line type error that's impossible to decode. So you'll sit there in like 30 minutes and try to figure out which type was it that did match. So we've been trying to figure out how to do that, and now it works quite well, I think. Yeah, and that's the main thing. And and then we have built some error handling on top of that, because we had problem with when a thread makes an exception, it goes
30 seconds.
Goes into the main thread, and then it's impossible to catch. And we've tried to like wrap those errors so it's easier to deal with. Yeah, that's
I think that's it. We love the language. It was very fun being here, and I also spoke with some other guys. It's kind of like Christmas here, and now we all go back to our small caves and go to our keyboards, and then we meet next year. That's very cool.
All right, we have time for 2 questions. Questions? Anybody? Here we go.
What's the most frustrating part of the lang for you?
I think sometimes when you're using some of the CTFE stuff, you can get some really long error messages that can be quite hard to interpret. But other than that, I think it's a very great language. But some of these error messages for CTFE, they're very, very long and quite hard to understand sometimes, I think.
Yeah, one of my long-standing rants about compile time programming, and especially templates, is that they're just a nightmare to debug for that very reason.
Yeah, for me it would be template errors as well. I think I've heard a lot of people complain about the lack of resources to get started with it. But I actually think that's quite great about D, because you have at least for the standard library, you have all the documentation, you have all the examples in one place. You don't have to go to a forum to figure out where somebody made something 5 years ago that doesn't work, where they do some weird stuff and you have no idea what's happening. I actually think that's quite a great part about it.
Yeah, so I just wanted to say thanks for the appreciation on the Discord, and I wanted to let everyone know that the Discord is actually a really good place to get help if you're looking for it. There's like people around the world that are usually using it, and most of us know a lot of stuff about D that we can answer the question. Oh, and you can get to it from the homepage and community. There's a community Discord link.
Cool, I think that was more of a comment than a question, but you guys got anything to add? No. Oh, well then, thank you. That was the last of the lightning talks. We had 8 good ones and whatever it was that Chris subjected us to. Now I think you guys are going to need a 10-minute break after that, so please back here in 10 minutes for the next talk. All right, everybody, back upstairs, back upstairs. Running a little bit behind schedule now, thanks to the fun that we had in the lightning talks. So, all right. So I was going to say that this is a first-time DConf speaker up here, but that is now a lie thanks to about an hour ago. You just gave us a lightning talk. But, you know, you can still applaud anyway. It's the first time full. And this is a hot topic, AI. Woo, look at all the money going into that. Now we have a beginner's journey in AI with the D language. So please, Murillo, take it away.
So is everybody hearing me? Okay. So thank you very much for receiving me here. I'm going to talk about how I started working with AI by using D-Lang. It began just as a play, and I did not imagine that I would end up as a speaker at DConf. Because it started as something that I was doing just because I was bored. And in the end, it grew to some extent to which that now there are some people who have been contacting me who are interested in the work I'm doing. And here, concerning AI. AI is something that when I imagined it, I thought about, you know, those robots, those things that you see, like computers that take over the world and things like that, androids, very smart machines. I imagined it would be something like that, so I thought, my God, it must be so difficult. I'm going to have to study so hard. And later, as I started really getting into it, I realized it wasn't really that difficult, because it turns out what currently people call AI, artificial intelligence, is actually very far away from any form of intelligence. Here. I'm not sure if you people have already seen this over here, or this one over here. So, I've discovered that what they call neural networks, machine learning, things like that, is just an application of the fields of statistics and probability. It just applied math. It doesn't really involve real intelligence. It doesn't really create an actual brain. It simply creates a system in which a certain path becomes more likely to be followed, whereas the other paths become less likely to be chosen. And therefore, if the test data is compatible with those paths, it will give you the correct result. And I have seen, more often than not, AIs that turned out to be nothing more than a bunch of if-else. I saw once a guy speaking. He was talking about a chatterbot, right? An AI that talks to you, and he said it is able to reply very fast. And the reason why it replies so fast is because if you look at the source code, it's just a gigantic list of if-else, if-else, if-else. So it goes through very fast. When I started studying it, I found this quote on the internet, which I found interesting. I did not understand what it meant back then. But nowadays, I get very well the point, because right now we're in the year of 2023. We have things like ChatGPT, right? And guess what human beings with their incredible creativity have been using AI for? I'm going to click here on a video. Oh, unfortunately, people cannot hear it, but it's okay. I think people can see here in the video. It's a scene from the film No Country for Old Men, and they managed to put the face of Arnold Schwarzenegger. If it had the audio, it would be way funnier. I keep imagining if people like Isaac Asimov, if we could bring them back to life and show them what we have been doing with AI, I imagine what their reaction would be.
I said, what time do you go to bed?
Which button?
Somewhere around 9:30. I'd say around 9:30. I could come back then. Why would you be coming back? We'll be closed. Yeah, you said that. Well, I got to close now. You live in that house out back? Yes, I do. You lived here all your life? This is my wife's father's place originally. You married into it? We lived in Temple, Texas for many years. Raised a family there in Temple. We come out here about 4 years ago. You married into it. That's
Okay, that was quite funny. Now let's go back here to what we were actually working on. So I searched for it and I was unable to find the tools to work with AI. It is not like in Python. In Python, you have so many tools. You have PyTorch, and you have also tools to work with data science, right? You have NumPy, you have Pandas, you have so many packages. I searched the package repository of dlang. I found this package over here, but I'm not sure exactly how it works, and I don't know if it really be useful for what I have been doing. So I hope there are more people there who have been using D for AI. So far, I haven't met anybody. I hope I get to meet someone here. And I hope that soon there will be more tools available in our community for AI, which is a field that at the moment, there is a big hype about it because they're using it for everything. So why is it that I use the dlang to do it? I could have used Python, right? But the thing is, it's part of my personality that I am kind of rigid. I like to do things the way I like to do things. I do not like to adapt to do things in ways that I find uncomfortable. So I did not want to learn frameworks like PyTorch, and I did not want to move to another language. I wanted to stick with the one that I liked. So I figured, well, if there are no libraries out there, I'm going to make my own. So I decided to use aid from other libraries. I decided to stand on the shoulders of other people. I used the ARSD library. I had studied very deeply because I wanted to learn how to make a computer game in D. And for that, I needed to work with multimedia. I needed to work with sounds and images. So I studied this library to the extent that I was able to make a pretty large RPG game purely in D. And then I figured, well, I could create my own D AI library that works at least here on my personal computer. And I could use, if I want to give it a GUI, I can do it with this library here. And that's exactly what I did. So my first experiments. When I started years ago, I think it was in the year of 2019, I first just made a simple agent that would find its way out of a maze with the A-star algorithm. So I simply got an image from the internet. I Googled Pac-Man, and then I found an image of that little maze, and then I managed to divide it into squares, And I made this simple software in which you could pick the square in which the agent starts, and it would find the shortest path to get to the exit. Something quite simple, but I found it interesting because it was done purely in D. When I showed it to other people, they kept asking me, so what did you use? PyTorch? Did you use, they kept listing all of those popular frameworks, and said, no, man, I didn't use anything at all. I did it all from scratch. And apparently they weren't able to understand that. No, it's serious, because I said it 3 or 4 times, and they continued to ask me which framework I had used. I made once a simple animation just to illustrate the, I don't know how to pronounce that. I hope it is Digikistra. Yeah. Dextra. Okay. Just in order to illustrate this algorithm in action. It is that simple algorithm to find the shortest path to get from one point to another on a map. So I made the software that you could place the points, the nodes, and then you could connect them to make the vertices, and then you could choose the one which was the start point, the one which was the end point, and then it would show the agent making the selection until it could calculate which was the shortest path. And later, I intuitively created an OCR, an optical character recognition software, inspired by the same idea used by Emmanuel Goldberg. Goldberg was a man who he created one of the earliest forms of OCR. I think it was in the early 1900s, which was a form of OCR based on light, based on the pixels, the white and the black pixels of a character, in order to read microfilm, in order to be able to interpret the text of a microfilm. Microfilm is like a small slide that can be expanded into a big text. And I made this OCR, and it worked reasonably well. So here, that's what I was talking about, the module that I wrote. I need a framework to create neural networks, because that's how it works. If you want to create a neural network, you have to create all of the neurons, all of the synapses. You have to create the learning algorithm. You have to create the back propagation algorithm. You have to create the algorithm which is going to perform the activation using the sigmoid function, although there are others. And I figured that doing it all from scratch over and over was too time consuming. So I thought, I'm gonna create a module that has all of that implemented. I just have to call it into my code. I just have to import it and use it all. And I made a module in a simple code with the name neural network that has the class neuron, the class synapse, and it has the function that the sigmoid function and the gradient function. And it has the main class, the flagship, is a class called network, which the network itself, which is going to draw on the neuron classes and the synapse classes. And then it is going to perform all the learning algorithm with the functions. And this class called the net, it is able to work by itself. It's very self-sufficient. So all you have to do is to give it the training data and let it think by itself. I use the classes instead of structs. I usually prefer structs, but I use the classes because classes go by reference. I needed all of the different neurons and synapses in the network. They had to be talking to each other all the time. They had to be exchanging information. So they had to be passed by reference instead of by value. And that's why I use the classes heavily instead of structs. Here. That's just a screenshot I took, the module neural network. It simply uses the ABS function of the math module from the standard library. Then it has the learning rate, the sigmoid function, the derivative. And I did not show the rest of the code, but here begins the class that represents a synapse. As you can see, my style of writing is super simple. I always try to stick to the simplest form of writing. I try to avoid making the code difficult to read. And I also I follow this rule, which to me is very important, the rule of always putting the first brace underneath and not in front. I find it very ugly when people put it in front. All right, then. Once I had finished this module, I figured, okay, now I have my own framework, but let's suppose that I'm making a big network, a network that has 5 layers, and each layer has 10 neurons, and there will be more than 100 synapses. I would have to be declaring them one by one. I would have to be typing there all of the neurons, then typing all of the synapses, and then reading it to make sure I didn't make any mistake. So I figure I'm going to find a way to automate that. I'm going to make a software that does the job for me. And that's what I did. Because when you're visualizing your work, when you're able to draw it, it makes it much easier for you to understand it and to check if you have made something wrong, instead of simply working with pure base, with pure text-based stuff, okay? Because when you're working with just the text, the chances of you having made a mistake are much higher, and then you can spend hours debugging it. So I made a software that you just draw the network with a mouse, connect it all, and press enter, and it creates it automatically. It's very, very easy to use, and I have been using it almost every day. Here, that's an example. You can see here there are 5 layers. I could add more later, but for now, the software only supports 5 layers. And then all you have to do is to right-click to create a neuron. It gives the name automatically. The neurons in the first layer start with A. The ones in the second start with B, and so on. And then all you have to do is to click on a neuron and then click on another one, and it already connects the 2 of them. And you can see each neuron has its own color. I decided to make it like this. Each neuron, upon creation, will receive a random color. That way you can visually trace back the synapse to see what belongs to who. So here, I know very well that the blue synapse belongs to A3. Over there, you can see that the green one belongs to C1. Some of them have colors that got a little similar because it is random, right? It could give very similar colors. But the idea is simply to make it easier for you to understand without getting confused. And here I placed the instructions, which did not appear here, but there is a list of instructions teaching the user exactly what they have to do. And now, okay. Later, I improved the OCR software I had made. I had to make my own training sets because it's like this. I searched the internet to see if I could find tens or hundreds of images of letters so I could fit into it. I found the MNIST repository, which is the most popular one. It has around 40,000 images, but when you download it, it is not in a format that you can see. It's not in bitmap or JPEG or PNG. It is purely in a mathematical format as a matrix. I wanted it to be in the raw image format. So I created my own training set using images. I would simply type them using several different fonts. I would use 25 different fonts for the letter A, 25 different fonts for the letter B. Then I would edit them using GIMP. And then I created this folder that had hundreds and hundreds of images, 25 images of different fonts for each and every letter of the alphabet for both lower and uppercase, and the numbers too. And I later placed it on the internet so other people can download it. So it's something that I was very proud of, because this repository I created, it is the only one of its kind. Like I wrote here, it turns out to be hard to find something similar, because this OCR software I made, it works like that. You open it, you type the name of the file, and then it opens the file, and it scans the file in order to recognize all the digits. You are probably not going to find something so easy to use. There are some few OCR softwares available there, and they are usually paid. You have to pay for them, and they can be quite expensive. I did not yet make mine available for people to download it, because I am still finishing some details, but later I'll make it available, and then it will be free to use. And it is 100% made in D. This is just an example here. I open this file, and then the OCR software scans it to find all the lines. Then it finds the frames of each and every letter. You can see here each letter has a green frame around it. And once it has found the frame of each and every letter, it goes through each one of them, scanning them, and then it shows an output string telling you which characters are written here. Oh, the color classifier, that was my second project. I had an idea. What if I make a neural network that I show it a color and it tells me the name of the color? Like, I show it the color of this background, and it says, that is purple. Or, well, depending on your point of view, you could state it is pink, but well, anyway. I thought it would be easy to make, but it turned out to be much harder than I thought, which may help explain why I didn't find anything similar out there. I do not think there is any software that you can simply download that does this kind of classification so easily. I had to ask friends for help to classify the colors, because I know nothing about colors, about the theory of colors. My software uses the RGB values, the red, green, blue values of the pixel. So it is a neural network that analyzes all of the relations between the RGB values in order to tell what is the name of that color. I had to iterate many times, refactor the code many times, and try many different architectures until it finally worked. Here, that's an example. Here, it managed to understand it was pink, it understood it was purple, it understood it was red, and it understood it was violet. It works like that. You give it a color, and it tells you the name of the color. It still confuses a few colors. I still have to improve some details, because there are certain colors that even people could confuse. Even people, depending on the shade of red, people could wonder if it is a red or a pink. Here, this is one of the early networks I made to classify the colors. The input neurons are the relations between the RGB, the value of the R, the G, the B, then the difference between the R and the G, the difference between the G and the B, the difference between the R and the B, the sum of all three, all relations I could find. This was one of the first attempts I made. The network creator, it still did not have the random colors. It was all green. Okay, I figured that my networks were getting big, training them was taking hours, sometimes more than a day. I have a simple old computer with an AFX 4300 CPU. It only has 4 cores. Try to use it while it is training a network and it becomes super slow. So I did not want to spend money buying another computer, so what I did was simple. I talked to people who were throwing computers in the garbage. I say, give it to me instead. I simply restored them, even painted them to make them look cool, and then I set them up so they spend the whole day there thinking. They sometimes spend more than a week running 24 hours doing the training of the networks. I have 2 of them, one with a quad 2 core and with a core 2 quad and another one with a core 2 dual CPU. So they are very old, like 15 years old here. This one here is my main computer, the one I use, and these 2 here, they are the trash computers that I have converted into thinking computers. I spend the whole day there doing the thinking. You can even see here the details because of the way I painted them. You can see. Okay. I still want to show you guys an example, so I'm going to speed up a little bit. My advice to people who want to learn AI, you're going to need to use a math. Knowing high school math will help a lot. You're going to need to know some linear algebra and some calculus. You're going to have to work with matrices and dot products, which is linear algebra. And you're going to have to work with derivatives of cost functions, which is calculus. It is something that you are going to take long because it is hard. It took me a long time until I finally understood it. You are going to read it the first time and you'll not understand it. Then you read it for the second time and you start to understand it. You read it for the third time and you have an idea. You read it for the fourth time and you begin to truly understand it. And then when you read it for the 5th time, then you finally understand it. And then when you try to implement it yourself, then you discover that you did not understand anything. And then eventually you finally get there. Oh, and try to get an intuitive understanding before going to the math. Try to understand, try to visualize how it works, and then you try to know all of the equations behind it. Okay, I'll show you people an example here. How much time do I have?
You keep
oh, it's right here.
Right below you, yeah.
Oh, well, turns out I still have quite some time. So, let me close this. Here, I have written 2 networks, one called the linear and one called the nonlinear. Here is the network creator, and here is the DMD GUI. I find the prompt something so primitive that I decided to make a GUI to use DMD. It's actually something quite simple. It simply uses the ARSD library to make this image, and then it sends all the command to the operating system later. It's just a wrapper, something quite simple. But here I can type the name, and then I choose the flags, and then I click on compile. There, and then I just thanks. Oh, it has RDMD too. If you wanted to just compile it and run it immediately, you can use it here. But for our case, this one is not going to work because it is using an external library. And then all you have to do is to press Enter to run. There. But I have to show you people exactly how these networks were built here. let's think of a scenario in which I have 4 numbers. 2 of them will tell if the result is true or false. Only 2 of them matter. Like this. Well, for some reason, it's not turning it black, but okay. Let me just pull out the pencil. And here. 2 options. Perfect. The color options, of course. Here, colors. There. It's working out. So, it's like this. There are 4 numbers. 1, 2, 3, 4. Only these 2 matter. The other ones don't matter. Only these 2 here. If either of them is 1, the result must be true. If either of these 2 is a 1, the result will always be true. The result will only be false if both of them are 0. So here, I call it linear network because this is something that in math they call a linear relationship. The things that they are related to each other in a linear manner. So here, I'm going to open the network creator. And there it is. So here, 4 input neurons. Everything you're seeing here, all softwares I'm using, they were written 100% in D. So these are the 4 neurons. And it will have 1 output neuron, only 2 layers. 4 layers is the minimum, so it becomes deep learning. So if I went all the way to the 4th, it becomes deep learning. But I do not need deep learning for something so simple. So here, I'm going to delete this guy and delete this guy. And now I'm going to connect these guys here. Yeah. Oh, by the way, there is the focus mode as well. If I wanted to focus on a neuron, I just have to right-click it. And then, no, this was a better, this one here, there. It shows everything that is directly connected to it. So like here, for example. If I focus on neuron C1, it shows me everything that is directly connected to it. If I focus on C2, it shows me everything that is connected to it. It is a way for you to be able to trace back all the path of the neuron if you are making a very large network and you are beginning to get lost. Once you select, you can also delete all of the forward synapses by hitting Control here. And if you hit Escape, you will erase the entire network. Now for our example here, let's just create a simple network that is going to understand that only those 2 values matter. Here, I've clicked it, and now I just press Enter, and voila, it's right here, network source code. There it is. It already creates all the source code for me. There it is. The neurons, the synapses, the forward synapses, the layers, the network, the learning rate. It's all there. It even gives me a list with all the weights in case I want to store the weights later, right? You often want to save all the weights in a text file so you can reuse it later. But here we're not going to need it. I just have to copy it and paste it inside the file where I am going to use it here. Here. I'm going to delete this one and put the new one. Here. Yeah, perfect. Here, that's the training set. And these are the answers, right? The answers to each one of them. I know it may be getting boring for some few people, but it will get amusing very fast. As you can see, just each one of them is just an array with the numbers. If either the first or the third is a 1, the answer will have to be a 1, 2. If both are 0, the answer will be a 0. Here you have all the network created. And now you just have to train it here. Now we train it many times. You can see the simplicity in my code, right? You can see how I use very basic features, right? Nothing fancy. No at safe, no at property, nothing difficult, no scope guards, nothing. It's very, very simple, very basic. Now I just have to get each example of the training set. I have to adjust the learning rate. Can you people notice that I have 16 answers, but 12 of them are 1s and only 4 of them are 0s, which means it will be increasing the values of the synapses way more often than it will be decreasing them. It will be considering to be true 3 times more often than it will be considering to be false. So in order to deal with this problem in a simple manner, I simply decided to adjust the learning rate. When it is the learning rate for the wrong cases, they will be 3 times bigger than the learning rate for the correct cases. I simply do the ratio between how many right cases, how many wrong cases, and the learning rate will be proportional to each of them. And I just have to make the network think net.think. That's all. Net.think, and it gives me the result. That's all it does. And then I get the error. And if the error is significant, it learns. I decided to tell it to only learn when the error is noticeable to prevent overfitting. So only if the error was 5% or more, then it learns. So it's just net.think and net.learn. These are the 2 member functions we're going to call. Quite simple. And then you just check if you worked here. You just test. Here, it's simply going to show you all the results after the training to see if it worked. So we train it 200,000 times, and then we check it. Quite simple. Let's see if it worked. Oops, this time it didn't work. I think I know the reason why. It's because it was not supposed to have this here. This was not supposed to be here. It still doesn't work. Huh? Of course, I forgot to save it. I was so focused on that, I didn't even save it. Yeah, it worked. Let's test it, and voila. Here, it got all the first 12 close to 1 and all the last 4 close to 0. The first 12 were supposed to be true. The last 4 were supposed to be false. This guy here got in the middle. It's because this case here was a special case in which all the inputs were 0. Here, it was a 0, 0, 0. If all inputs were 0, that means there will be no activation. And as a result, when it goes into the sigmoid function, it gives you just 0.5. So it's kind of like if everything is 0, the network doesn't know what it is, it chooses in the middle. Now, let's try it with something more complex here. This is a non-linear network. Now it is different. Now, I have a problem in which okay, here it is only going to be true when one of these guys is 1 and the other one is 0, like an exclusive OR operator. So it is only true if these two are different. If they are equal, if they are both 1, it will be false. If they are both 0, it will be false. But if it is 1, 0 or 0, 1, it will be true. Let me close this. Here, that's the non-linear network. It's the same thing, but the answers are different because the answers had to be changed, so it will be equivalent to what I just said. Now, let's create this network. If I create this network like this, it won't work because the network was too simple in order to be able to understand this problem, which is more complex. So here, I just have to go down here. Here. I'll put it here. Now, save it. Now it is non-linear network. Non-linear network. There. And it gets everything messed up. You see, it's a mess. So I'm going to have to make this network smarter. Think of a rat. By adding more neurons and synapses to his brain, he will become smarter. So that's what I'm going to do here. I'm going to add more neurons here. I'm going to add here. I'm going to add several of them. So I'm going to, you have to think about the associations you're making. I'm going to use one neuron that associates everybody, one that associates only the first two, one that associates only the first three, one that associates only the second two, one that associates these, one that is going to associate these two, one that is going to associate these, no, not this one. No. 2, 3. There. Here, and these two will be associated here. And now, there. Okay, generated it, network source code. A brand new source code much bigger than the previous one. Now I just copy it and paste it. Put it right here. This place. There it is. Now I can. Okay, let me close it. Close. It will take longer now because the network is much bigger. It will have to think more. But guess what? It worked now. Now that I made it more complex, it was able to understand that the relationship wasn't merely if this is true or if this one is true. It understands now it has to be when they differ. So I had to draw many associations, many connections, and then it would use all of those associations connected to one neuron in the third layer in order to understand how it really works. This is what they call a non-linear relation. In this case here, this guy over here is very important because this guy is the one that associates these two. Well, I think this is pretty much it. I still have 2 seconds. Does anybody have questions? Thank you.
Yes. I do have one question. Do you consider implementing other type of connection, like for example, convolution neural network? Have you looked into that?
Yes, exactly. At first, this thing here, it only does a feed-forward network, which is the simplest one. It's the first one you learn. Yeah, so far it only does this one because it is the only one I know how to do so far. But as soon as I learn how to do the others, it will do all the others too.
Cool. We have an online question from NX Leet. Is there a practical reason to create a color recognizer with neural networks instead of just converting it to some other color space and writing a bunch of if statements?
So the reason was simple. It's because I wanted to start my own project so I could learn how to do it myself. It was something that I did for educational purposes. But if you're wondering about a practical reason, because there are so many different colors, I would have to write so many if statements that I figured it would be easier to make a network that figures it out instead of me having to sit there for 20 hours straight typing approximately 600 if statements.
Hello. In the GUI you have, maybe I missed it, but can you configure the activation function you have at each like node in the graph?
Oh, no. So far, it only uses the sigmoid function as the activation, and you cannot change it yet. So far, it is very rigid so far. Later, I will add more features so you can set up a different cost function, a different backpropagation algorithm, and so you can also try different architectures as he had pointed out. But so far, it only uses the sigmoid function as the activation function.
Mm-hmm. I'd also just like to know that people were giggling at the sounds, but I think that kind of like the sound is a very underutilized aspect of computer interfaces when done right, at least.
Can you please speak louder? I didn't really hear it.
I was saying that sound is a very underutilized aspect of a computer's user interface. So if you have like a really long build, which ideally wouldn't exist in the first place, but if you did have a really long build, having it beep is actually
I see. You mean in my network creator, I could have put some sounds as I created, like.
I was talking about the build tool. Having the sounds there is very nice.
Oh, okay.
At the beginning, you mentioned that the AI stuff isn't actually intelligent because it's just following weights and summing them up and deciding yes, no. It's completely deterministic. I think that kind of reframes or frames the question the wrong way, because I look at it as, are we intelligent, or are we just simply a sum of probabilities and weights and have a deterministic thing? Because once I learned how these neural networks worked, I found a lot of similarity with the way my own head works. Okay, and I can't escape the idea that maybe we are just neural networks with a sum of weights and come out with a deterministic thing, and we're not actually intelligent at all.
Yes, I totally understand that. I once met a guy who said, stating a computer cannot be intelligent because it is only able to execute a set list of CPU instructions is the same as stating that the human brain is not intelligent because it is only able to execute a set list of physical and chemical phenomena. But what I mean is, our brains, they have so many different neurotransmitters, and they have so much complexity. And when you look at the neural network, it's something so crude and simple that it makes you feel a little disappointed, because when you hear the word the neural network, you imagine something so complex, and when you look at it, say, is that it? That's what you call a neural network?
Maybe that is it. That's what we are.
All right, we'll have to cut the question short there, but thank you. And it sounds like Mike has something to say.
Yeah, when we go to break now, if you want extra T-shirts, coffee cups, swag bags, take what you can. First come, first serve. They're all yours. They all got to go today.
Yeah, I was meant to mention that. Guess what I didn't do? All right. You guys have 5 minutes. We're running a little bit behind schedule here, so we'll keep the break short until we're done for the day. So go have a quick one. Alrighty, we're good to go, and I hope you are. Come on back upstairs. We have another talk. Took them a bit, but they finally got to the programmer energy bit. Yeah. How you doing, Max?
Very well.
Very well, very well.
Very sleep deprived.
Yeah, well, I mean, it's either you're hungover or you're sleep deprived today, right? Yeah.
Not yet.
Look, there's enough people up here. Let's kick this off because we are running behind schedule. Max is going to talk to us about large language models in D and a bunch of other stuff. So take it away.
Yes. So, icebreaker, little survey. Put hand up if you consciously use AI. Emphasis on consciously, and hands stay up if you regularly use ChatGPT. Today, 10 minutes ago, because it's currently down. And who has like an API key, for example? So don't need to explain too much, but I have a slight confession to make in that this, when I drafted the proposal for the talk, I was thinking basically the open source models will massively progress in like the next, it feels like a very long time, but it's not, the next X months or so, and also, and I shall demonstrate, influencing them with, whatever I happen to have on the stage, and that basically hasn't happened. So I've, despite forgetting to change the description of the talk, I think the content of the talk is effectively going from gritty technical stuff to more sort of soft philosophical stuff about what the existence of language models, but imperfect language models, actually means for us as programmers. Also, I just think that picture's funny. So, basically the only kind of bit of jargon that I think is actually needed, because it's not a theory or even necessarily a implementation talk, is effectively the term large language model, which for our purposes you can view it just as a giant blob of maths, just for predicting the next token in a list of tokens, which can be, like I've just downloaded a few of them, can be anywhere from basically the size of a small USB stick to say if depending on who you believe, OpenAI, their work could be anywhere from a hard drive to a whole rack of many hard drives. It's like there's a lot of shades of grey in terms of what you can actually practically mean, and it's not about the I don't really want to talk about their design, partly because I'm not an AI researcher, but also because they're so astronomically complicated, astronomically difficult to train economically, that it doesn't really matter for the purposes of the things I actually am interested in. But there's a framing question in that we're not AI researchers, but we are programmers, but we also build things for people to pay us money, hopefully, and produce value. So at the end of the last talk, for example, there's a question of is a neural network of any kind, or even a computer of any kind, or any deterministic, even if you somehow inject a bit of randomness in there, algorithm, whether it can actually be intelligent. But I don't think it matters, because they might be useful. Is the rub. I've mentioned the term compression here, and if you've overheard a bunch of us talking about this downstairs, it's just that there's a lot of industry focus on compression, or rather, so for example, there's a quite famous prize where you can win money for just getting like a fraction of a % better at this point on compressing Wikipedia on the basis that it's a very attainable goal, which might be a useful heuristic for some kind of intelligence. So in a ideal world, if you set the problem up right to be able to compress Wikipedia, you might have to have some kind of semantic understanding of what the text actually means in theory. But it potentially doesn't actually matter to us as programmers because we already because they're effectively just another arsenal of tools, whether they're intelligent or not, or whether they're good at compression or not, unless you actually want to use them for compression. And this is one thing that has dawned on me recently is that all of this AI stuff has been brought about basically by, at very least, people who are writing code and programmers. But I think a lot of the value and the treasure you can find by using them is actually often not in the same patterns that programmers like to exist in. So, for example, I think some of the most interesting things I've heard about people using AI have been people who either are learning to program, or people who wouldn't even dream of ever programming. And I think this is an important thing to internalize because you can look at it these tools as just their thing. Well, oh, it can write code for me, and they can. They're getting in some places frighteningly good at it. But as programmers, if we want to integrate them into systems, it might require a different way of thinking about how to actually use them. And a obvious thing you probably, if you either young enough, have children, or just read the news, some of the most interesting things I see are basically people using these AI tools to. I've put a strike through this, so that, so it's not libelous, but potentially cheating on their exams. But even if they don't realize that they're inadvertently shaping the kind of the cult, they are the next generation. So they'll probably look upon us as idiots who don't understand the way to effectively use these tools. And I find this mildly interesting. If we do some kind of so basically like technical analysis, if you imagine the sort of the classic hype curve, we're either on it, going in the sort of we're past the hump, going down, or it's currently school holidays in the West. Make of that what you will. Both can be true. Both can be interesting. It doesn't really matter. There we go. There are a lot of really. Hello?
Just to be clear, the diagram is, I think, GPT usage numbers, right?
Oh, sorry. It's the Google.
Oh yeah.
Just Google search trends. And I don't know how reliable it is as well, but the average. If you go on like Statista and look for the data, I don't know where they get the data from, but the data they have on the age distribution of people using ChatGPT, the bucket that starts at 18 is suspiciously large. So there's presumably a bunch of people who aren't 18 yet being lumped into that one. And I think that's where this pattern. I was trying to see if there's any data from somewhere in the southern hemisphere that I can look at separately, but I couldn't find any, or at least I couldn't easily find any. There are a bunch of things where you can immediately see these really tricky, weird, fuzzy problems which these things can potentially solve. So for example, during the Linux distribution talk yesterday, it struck me that you could, in theory, have a AI watch your bash history and work out how to kind of prettyify you trying to like hack together something that your build system doesn't like, but in a way that you can actually reproduce it. And if you had a transactional system like proposed in that talk, you can just go and try it, for example. But that doesn't actually mean we can actually do that today. It's a bit like saying, oh, if I had an identical version of myself embedded in the computer, then he could probably go off and go off and do something for me. But the interesting thing, I think, is that there are a lot of things which are very tricky, but almost possible, and that they require a bit of help, but they're almost possible. So this is probably familiar to everyone, but there are basically, in terms of the models you can readily access programmatically, you basically have a choice of the OpenAI models, i.e. ChatGPT, and a smattering of open source ones. There are a few other things which have APIs if you pay them a bunch of money, but for the purposes of my slides, I'm saying this is what it is. And the kind of the hubristic delusion that I had when I proposed this is that the open source models would without being effectively improved on an individual task would be much better by now, and they're not, hence still a bit crap. But you can see, and I can potentially demonstrate at the end, they are already for an alarmingly small amount of data, very effective at sort of babbling like a baby, in a good way. And if you consider, for example, stable diffusion, which isn't the same architecturally as ChatGPT, but shares some insights. I don't know how big the kind of a cutting edge blob of like stable diffusion weights is, but it's not very big, and you can get all of that content from it. There's an element of magic there. And one thing you may have seen is there's a new Facebook of open source, a new coding model recently called Code Llama, which is getting there, but is nowhere near as good for the things I'm about to discuss as, say, ChatGPT. And a specific example, which I think I got the idea talking to Attila potentially, is if you imagine every tool, basically with the exception of import seek, it's a slightly different way of thinking about the problem. But if you imagine when we want to bind with C and C++ libraries, you'll hit a wall where you have to translate by hand. The tool basically, without having 1,000 special cases embedded, it can't translate these. This is a relatively simple one, but like C programmers love doing these completely idiotic it's true. They love these like idiotic macro patterns, and we can immediately see. That's not a pun. We can immediately see what we need to do to translate it, but actually programming a computer to do it, unless you get either very clever or have big or are extremely patient, is very hard. But it's the kind of sort of slightly fuzzy, roughly linguistic problem that you'd expect an AI to be able to do, and they can. Except they need some help, which brings me on to the next thing. So this is if you just ask ChatGPT to do it, you'll end up with something. One of the things that it gave me is this, and you can see it's basically gibberish. If you imagine we're replacing effectively just that expression or expression to be, because it's in the preprocessor. But it's like object.tupelov alias. It's gibberish, but it also knows most of that the pieces are actually there, which I think is a very good start. And the thing is, if you give it feedback, because you can question.
More of a comment. I've been struggling with this problem with import C, and currently import C only handles trivial macros. But if you go back to the macro, you see it's obj.field equals set. What does that look like? It looks like a statement. Okay, and I haven't implemented this, but I realize that what the compiler can do is try to parse it like, is this a statement? Does it fit the grammar of a statement? And if it does, then you can translate it to a lambda and set by name is a lambda that does that, and it should work. And you can, does this parse as an expression? Does this parse as a function? And that will take care of a large number of those macros, but a much more intractable problem is one like the hash begin open curly brace hash and the close curly brace. The macros that sort of have an unparsable or an incomplete syntax to them that you need multiple macros to build up that one. I don't know any way to solve that problem, and I don't know how an AI could solve it either, because it's not a self-contained problem, because it's distributed over multiple macros.
Honestly, ironically, I would expect an AI to have a very much easier time with begin and end, because like AIs are very good at skipping irrelevant details. Unless you're doing something evil like define begin closing bracket, it's probably just going to see begin and it's going to be like, it's going to figure it's going to be an opening bracket. It wouldn't even have to look at the actual definition to figure that one out.
Yeah, I mean, well, one thing that can help both with AI or any other, like it's effectively old-fashioned AI. If you start guessing by just seeing what it passes like, which we should be doing. But one thing you can do as well is if you're lucky, you'll have context to look at. So you can potentially see the pattern. One thing I'll get onto is that if we completely restructure the way we actually look at the problem, we can potentially get the absolute maximum from the tools we have available more easily. So if you imagine at current rates, the models we have available to us are improving. Without making a prediction, but they're improving. So you could just wait until it can just nail this first time. And, we get lucky, and OpenAI starts scraping. I don't know, start scraping every dub project or something like that. Maybe we could bribe them for. But it's something I've been thinking about for a while. Is if you imagine there's a lot of like fuzzy details which are difficult to in a kind of complexity sense, that they're very difficult to solve, but they're quite easy to check. So maybe we just need a more interactive way of doing this. So for example, I don't know how well it would work for import C and DPP, but if you imagine if you're generating C bindings with a tool like dstep, maybe you should just be interacting with it as it goes, because I often have to fix them up anyway afterwards. And one of the things with these the more recent approach to AIs where they're instruction driven is that if it interprets the instruction sort of 80% of the way there, you can often give it either very direct feedback. So for example, if it doesn't quite know a programming language, but it knows how to program, it has some intuitive notion of how to glue Unicode together in order to make a computer do something. You can give it a specific thing, and it will be able to interpret your instructions, saying, "Oh, just put a semicolon there." But also, you can just say that's wrong, and it might be able to guess its way through that. And I also think if you were going to use some kind of if you were tomorrow going to do this with some kind of AI tool, you're also probably going to the energy costs of doing it are actually very high, so you probably want it to be interactive anyway. But with regard to changing the way we actually approach this kind of tooling, I think you can make an analogy with the work around driverless cars. And cars in general, for example, if you have a problem which is sort of half social, there's a bit of technology in there. Can you trust people? Things like that. You can, but say for now you're a paperclip maximizing evil AI, let's say, and you want to just make driverless cars work. No one should ever need to drive a car again. Which I don't think that's a good thing. But if you just suppose for now, you could either work really hard on the road network, or on the car, or you could potentially change the road network to make it more easy for the cars to work. If you're sufficiently incentivized to do it, so we can potentially extract a lot of the sort of the slightly murky, because it's a new field, treasure more easily just by being experimental enough to try new approaches that fit more with the kind of the unearthed power that we're trying to harness, which I think used to be something of a goal in the past. If you imagine, if anyone's ever written raw tech, rather than LaTeX, but raw tech, you notice that a lot of the commands and error messages very much form a dialogue with the computers. That could well have been what Donald Knuth had in mind when he was coming up with it. And on some more practical stuff, even though I don't think it's that interesting, to be honest. Prior to effectively sort of the AI explosion, at the end of last year, you had a very kind of big tech and academic dominated field of software. So where things are very clunky and often churning quite a lot because people need new things to do research with. So for example, running import torch in a Python script on my laptop to this day. So importing PyTorch is, it's a common deep learning library. It takes 1 second just to import it, and you haven't even run any code at that point. Whereas spurred on by all this it's the kind of AI boom, you have a complete vibe shift towards the kind of more traditional kind of hacker archetype, where people who actually know what a memory map file is, swooping in to avoid massive amounts of overhead. So the case in point being it's called llama.cpp, but the bulk of the code is actually a C library, which is a specifically special case just to run the Facebook llama model, but has been successful enough that people have sort of glued other things into it. And even though it might be asymptotically worse than a lot of the other offerings, because systems programming languages are very good at this kind of very direct task, it's much faster and the latency is much lower than the things that has effectively displaced. And luckily, because we have 20 years of work in talking to C and C++, it's actually very easy to make it work, with the exception that I think on this laptop you won't be able to import C it because the preprocessor I'm describing a bug report. The preprocessor thinks it has Neon, the ARM SIMD instruction set enabled, which will then enable 16-bit floating point types, which import C doesn't have, although D should have, and will need to have in the future. And speaking of PyTorch and the more kind of the kind of very large big tech, PyTorch is basically a Facebook invention as far as I'm aware. And Google's thing is TensorFlow, and they do very strongly reflect the styles of the two companies. There are a lot of as things don't just need to scale, but actually need to perform well at every scale. There are a bunch of kind of old old established techniques. So basically compiler optimization is being needed to make these AI models go faster. So that might be too small, but this is it from PyTorch, where they have a very, very standard kind of compiler engineer's old favorite common sub-expression elimination. Algorithm, which they need to make the models run faster when they ship them off to either a CPU or primarily a GPU, because it isn't good enough just to be able to have a very flexible library that you can just throw 1,000 GPUs at now. It's actually there's actually very real economics here, which brings me on to that. I think this field where it requires a bunch of very different styles of programming and thinking in the same within the same project or product. So you want like a very clean kind of Python-like experience in specifying the model, but you also want to be able to do your own memory allocators properly and know exactly which SIMD instructions you're getting, and I guess Nicholas is here, so also write GPU kernels nicely. This is something that I think D can do extremely well. Because I think we have a very nice language for doing that kind of thing and keeping the complexity on track without having to use. I don't know how many. There'll be at least 3 languages on the go inside like the main PyTorch library, for example. Whereas we have I think a unique gift for combining the best of quite a few different approaches in a people-friendly way within the same project. And so basically, we need to do a machine learning library. And there are there's stuff to use that already exists. There's a library called Grain, which seems quite promising, Vladimir has done one, but I think they're all they're either solving a specific problem, which might be slightly too isn't necessarily general enough, and also just sort of nitpicks I've found with them. But I think next DConf is when I'd quite like to have something. Have something general, because the idea with this one was really just to rush directly to just the things you need for language models, but I think that would have been quite silly. Whereas I have quite a clear idea of how we can do this really well. And I don't have an ending slide, so let's basically ramble over. But please ask questions.
All right, sounds like question time. We're going for a VJ first by the looks of things.
Testing 1, 2. Oh, sorry. In the Python world, one of the things that they're able to build upon that help them move very quickly is there's another library called NumPy, which takes care of all the matrix and linear algebra processing, and it converts it into CUDA instructions to run on an NVIDIA card, all that stuff, and it makes building things like PyTorch much faster because you're building on something that's already been highly optimized. In D, is there an equivalent of that yet? Can the mirror library do that, or are you familiar with anything that's really good at optimized linear algebra in D?
Well, I mean, last time Ilya benchmarked it, at least Mir was faster than NumPy on quite a few things. But I don't know if that's. I can see that being true when these libraries were coming about, but I don't think I would imagine that PyTorch, for example, now can work without a NumPy dependency. You basically have to roll quite a lot of this yourself, because a lot of the problems aren't just actually just doing the operations. You have to build a lot of scaffolding to be able to provide both a programming API for the models to be expressed, but also you need a bunch of internal APIs and knowing what not to expose in an API, such that you can, for example, if you specify a model as a whole bunch of it's basically a graph of operations, you want to be able to do optimizations on it. So in terms of the actual total amount of work you have to do to get impacts quickly, you'll want a fast linear algebra library, which we have, but I don't think it's actually what stops things like that. It's like there's already a mirror-based automatic differentiation library. I mentioned it just now. It's called Grain, and I think there's Grain 2 as well. But I think I couldn't get it to work last time I tried it. So basically, the short answer is yes, and also it's and the longer answer is it's complicated.
Okay, talking about this sort of, as I understand the way PyTorch works, you're feeding in data in a given format, and you sort of, in Python in the background through the operators you apply, or even through operator overloading, where D could have some advantage, sort of builds up this graph of the actual operations that are being performed, and that then gets compiled into whatever backend you're using. If you've been playing, like if anyone has been playing with this sort of stuff, I think one of the most common experiences is I tried to run this and it crunched for a minute, and then it gave me an error about the matrix sizes not matching up. It feels like this is something where something with a strict type system should be able to have an advantage, like being able to declare variables that actually state what data format this variable is expected to be in, and have that be type checked across operations. Does it seem promising?
Yes, and you also basically want dependent types. Which obviously you're buying into a lot with that, but I think there's a Scala library which gets quite a lot of the way in terms of the ergonomics of having a dependently typed system for checking the operations you're doing. But yes, although when I've been fiddling around with this stuff, I actually tried to keep the typedness of the API quite minimal, because there have been a few things where, without commenting on specific things about people's work who aren't here, there are some patterns where you can basically try and be too D for your own good. It's a bit like everyone C++ after working out, unless you have extremely perceptive taste. Everyone C++ after bumping into the way the STL is written. For example, you can try and do too many things, or I'll try and do this at compile time. It doesn't actually matter, but you effectively buy into a bunch of decisions that you can get stuck with. But it is a very real thing where, despite the ostensibly extremely fast development model that you might subscribe to with Python, the systems they have are actually very susceptible to weird things breaking halfway through, or massive complexity, leading to poor performance and thus throwing away any feedback you had. And I think people basically know this now. I think anyone who has a independent of their whatever their use of PyTorch is, programming background, I think will have pretty strong opinions and experiences of how they would improve it. But it's obviously very difficult to do, because it's a very extremely quickly moving field.
We have a question from the internet. Serg is querying what the status of auto-diff is in D.
Depends on what you want. Is the it's very so one thing I would quite like to do is Everyone who knows what a dual number is? For forward mode or forward mode automatic differentiation. So basically, by designing a something that is algebraically a little bit like a complex number, you can just do the operations, and then as long as you set the you have in a programming terms a struct of two numbers, and then you just keep track of the derivative next to the number, and then as long as you basically set the derivatives at the beginning of basically the bottom of the tree right, by the time you get to the top, you'll end up with a number and another number, and the first one will be the calculation you're interested in, and the second one will be the derivative of what you've calculated, provided you've done nice things. And that kind of programming is quite easy to do, but there are other techniques which are much more complicated. And speaking of complexity, there's a mere library for doing it called ediff, which I don't think there's any documentation for, but it will actually build the expression tree at compile time and then propagate the derivatives backwards, allocating the memory statically because you've done it at compile time, which is very actually does seem to be quite good for a lot of scientific problems, but it depends because there's very different scales involved. And if the type of automatic differentiation that you would want for, say, you might want for a physics problem, might have a handful of parameters, and you might be interested in, say, you can actually do this. You can run like a fluid simulation and calculate the derivative of an individual part of the simulation with regards to the starting parameters, depending on what the simulation is. But if you have a machine learning type problem where you might have the order of something like 1 billion things to wiggle, you need a very, very different style of programming to be able to capture
Looks like we have 2 questions left.
Max, thanks for the talk. Just a comment and then the question. The comment being, I completely aligned with your notion that D is an amazing fit for this, in that it spans from the basically Python-esque type stuff all the way down to the metal. So I think we have and also the metaprogramming stuff, very, very important in this area, I think. So very excited about that. But the question, I guess, is where do you see the problems in basically bringing us forward? What areas need focus? I have a couple in mind. The types that you talked about, the various reduced precision types and things like that. You've mentioned a few, but I was just wondering if you could kind of give a highlighting of where you think the effort needs to go, or do we just need to explore it a bit to find our way?
I think the current state of affairs is very much such that we'd be primarily limited. Like if we started and failed, it would be on us rather than our technology. But I think one thing that does come to mind quite frequently is when you start leaving the prototype phase, or rather in a performance sense kind of prototype phase, when you want to start doing interesting stuff, where you want to be able to cleanly use every bit of performance the machine has on the CPU or potentially the GPU. That's when you can the aspect of D where you have 2 compilers. Even just from a kind of developer onboarding perspective, can get quite ugly, in that there are a bunch of things where even though like DMD performance isn't an issue, but with say LDC and GDC, they both have slightly different or completely different, or sometimes the same but with different names, way of accessing the shiny stuff. So for example, if you want to emit the same code multiple times for different architectures inside the same binary. Is there a question? Okay, but basically the specific example I'm going with is if, for example, you have you know you're going to ship things to machines that some have AVX 512, for example, or some have like weird dialect of AVX 512 that doesn't quite have the instruction you want. There's a GDC-ism for emitting the same code multiple times with a different instruction set, as long as it's still x86. And if you want to use that, you get locked into things. So every got all this like weird version this, version that, effectively C build system style kind of preprocessor hell, but in D. Kind of time up. Nope.
Yep. Yeah, you talked about compressing Wikipedia. There's actually a project already to do that called OpenZim. So basically, it deduplicates the articles and compress it with Z standard or other algorithms. And you can actually do Z standard maps. So you can train a data set with common words on Wikipedia to make compression better. So what would be the use of AI in that sense to compress Wikipedia better?
Do you mean what would be the practical benefit, or to a researcher?
Yeah, the practical benefit.
I think the practical benefit is you're very much at the point where it's a battle between you and Pareto, and you're losing. So, for example, Fabrice Ballard, like FFmpeg, etc. He wrote he has a library called libnc, which is basically a C only plus CUDA, which I guess isn't C, automatic differentiation library, and he at one point had the record for one of these compression benchmarks, but then he started fighting for it, and then you'll notice that it can compress on any machine, but you have to be on the same hardware to decompress. So they're very much in the fighting over small wins in the hope of discovering interesting things about how these models work and learn and also insights into how to overfit the data set and so on. But then they're not training generic with the some of these benchmarks. They're not training a generic like model that compresses. Is the kind of the rub. So it's very much not aimed at improving, I don't know, like improving network throughput or something like that. Like Z standard is very good. It's genius.
Yeah, it's a good thing to see if we can go even further in terms of research on that part. But yeah.
All right, that's it, guys. Thank you, Max. All right, we're going to have a quick 5-minute break, and then it's that time of day that everybody's been waiting for, the Ask Anyone Anything panel. All right, everybody, I hope you're back, because it's time. Mike, would you care to do the intro for us for this panel?
This is everybody.
Programmer Energy, come on.
All right, everybody knows that normally the AUA is just Walter and Attila, but this year we expanded it a little bit because there have been a lot of changes recently, and we figured you might want to ask some questions about those. Now, recently we set some high-level goals to strengthen the community, enhance the ecosystem, and stabilize the language. So these two guys are in charge of the stabilization. Matthias and Robert are in charge of the ecosystem, and I and Ali are in charge of the community stuff. So we didn't want everybody up on stage, so Matthias and I are representing the community and the ecosystem. Ask us anything you want, go.
And that includes online. I am keeping an eye on Discord and YouTube, so by all means, ask away. Vijay.
When I'm pulling double duty, if anybody needs my mic, let me know.
In the scope of like the next year or 2 years, what do you view as like the highest priority focus for D, or the highest important area for D to move into? And what group of people do you think this relates to? Like, should D be more involved in machine learning or game development? What arena would capture the most interest and utility out of D and might attract corporate sponsors, et cetera?
We started this year talking about cleaning up the D language and removing obsolete features. Well, this turned out to be the completely wrong direction, because we got a very large pushback about breaking people's existing code. So we're going to learn from our mistake, and the focus for the near future is to compile legacy code. Legacy code is not going away. People really, no matter how easy it is to fix legacy code, it's always a barrier, and we're going to stop forcing people to upgrade their code. And we're going to add the concept of additions to D in a not quite yet determined way to do it, but we have a new priority, and that is to not break people's existing code. And once we get that to a reasonable state, then we're going to start looking at enhancing the language and things like that. But right now, our focus is on fixing bugs and making legacy code work without error as much as we can.
And on the library side, I want to not have anything in experimental anymore. The only thing left is allocators, so that would be great if we could finalize phobos before even thinking about version 2, because version 1 still, I think more people would even consider it if it just weren't experimental. There's a psychological thing about it, which I understand. It makes complete sense.
Okay, before the next question, I want to say I overlooked Dennis. Dennis and Razvan, of course, are our pull request and issue managers, and they're also our workhorses. When we need bugs fixed, we throw at them. And so I asked which one wanted to join us on the panel today, and Dennis volunteered. Yes.
Thank you. I want to point out how much Dennis and Razvan contribute. I mean, they started out as the greenest of greenhorns with D, and they've really grown into some pretty fantastic contributors to D. So we all owe Dennis and Razvan a big thank you.
Yeah.
When do you think that import C would be available generally?
When will import C be available?
Generally, also in LDC.
It's available now.
Also in LDC?
Yeah, it's in the
Wow.
compiler. It works.
Then I'm too late.
The main difficulty with import C is not compiling C code. It's compiling all the weird C extensions that appear in the header files that apparently the compiler vendors cannot resist constantly adding weird things and not providing a C route through the header files. It always has to be through all these bizarro extensions. Like one of them was expanding the assert macro to be statements. And everybody knows that you can't put a statement inside of an expression. Well, it turns out that GCC has some weird extension where you can actually insert statements inside of an expression. And there's no reason to do that with assert, but you know, whoever wrote that somehow decided that they must do it this way because, oh, look at that cool Giga, I must use it. Well, I found a way to make it work, but that's a thing where constantly gets stuck on is some weird extension. For example, Stephen was just showing to me how the default route through the header file was using all these strange SIMD intrinsic functions, which of course don't exist in DMD, so we're going to have to try to figure out what are we going to do with that. I figure that's probably going to be a constant problem. No matter how many of those we fix, the compiler vendors are going to keep adding more of garbage like that. So it'll be a constant problem. But other than that, import C is working. And even if you got to tweak something to get it to go through the headers, it's a hell of a lot less work than Stephen had to do trying to import these. Which library, Stephen, were you importing? Raylib, yeah. Yeah, some graphics library header file. So.
Okay, one more thing. You've all had the opportunity to meet Saeed over the last few days. Why is he up here on the stage? He's going to take any general questions you guys have about Ivy. Now, when we went through the Ivy program, it was a challenge for us to get into the mindset, but Saeed led us there very effectively over time. And as we implement what we learned, he's been coaching me and Walter to help us be more effective with it. So if you have any questions about our experience with Ivy and how we're applying it, we're happy to answer that. But Saeed will be here to answer any questions you have about Ivy in general. Yeah? And I really want to thank you, Cora, for offering us the opportunity to have this program. It's been very helpful to us.
When I talked earlier about our shift in focus of what we're working on with D, Ivy. Yeah. It's thanks to Saeed's work with us.
All right, we have a few questions from the internet here. I'll try and keep them brief. First one is to Dennis. Yeah. If you will be BDFL, it asks which 3 things you will fix or improve first, but let's just stick to one. What would you improve first?
Oh, that's really difficult. I mean, I would really like DMD to be used in Visual Studio Code or just any editor. Like currently, because I'm so involved with the compiler development, sometimes add a little hack like, oh, I want to know, is this import used? I quickly hack up some global variables inside the compiler, and I use that to refactor DMD. But like the general user doesn't have the privilege of that. Like they shouldn't obviously do something like that. I want DMD to just, all the information it analyzes, don't throw it away. Also give the users an opportunity to query that and use that for linting, refactoring, because manual refactoring takes so much time for decode. So yeah, working on better tooling, and I have to come up with 2 more.
No, let's just keep it at 1. We've got other questions to be asked. So yeah, anybody else watching at home, if you ask me for multiple things, I'm going to ask them for 1, all right? So stop asking for multiple things. Okay, second question from the internet for Walter. What is your plan for making the DI generator be able to produce DI files for both static libraries and shared libraries when annotating with export? And that's a question from Ricky.
Ricky and I have gone around on this a couple of times, and I have a pull request to make DMD behave a lot like C compilers do on Windows with DLL import and DLL export. However, that requires the writer of making a shared library and using them aware of how DLL import and DLL export works. And Ricky wants to do a mechanism where the user or the programmer would not have to understand how DLL import and DLL export work. And his idea is that it should just work. So currently we are not agreeing on the right approach on this. So the issue is unresolved.
Yeah, he's asked me to talk to you about it, but you know, I have my own opinions on DLL stuff, so that's definitely a discussion for DConf, I think.
Yeah.
Anyway, we have one more question from the internet before we get back to some audience questions here, and this is a general question. Is there any potential, this is from Lauren DB, sorry, is there any potential for future versions of D to turn on safe by default?
Okay, that was the plan. Unfortunately, that would break every legacy piece of code out there. And we want to continue to support legacy code without special switches and or by default. And so then we're looking at maybe doing something with editions support to turn this kind of thing on. So that's probably the direction we'll wind up going with that.
Yeah, I can't see us being able to do it any other way and not break people's code, which we really need to stop doing.
Cool. Then let's get back to the audience questions.
This is for Walter. You said that every C compiler vendor is doing their own thing, so does that make you hope that if DMD does its own thing and adds arrays to C, other compiler vendors might follow since they already do so much custom things?
I mean, I don't really understand the question. Are you asking what is the worst thing I've seen?
No, that I am asking, is your hope that other C compiler vendors will follow when DMD adds arrays to C?
I'm
that thing that since arrays are pointers in standard C, and if I recall correctly, DMD is adding real arrays to C.
He's asking if you think C compilers will add array slices to C because of as an extension to the language.
I've never made an official change proposal to the C committee, but one of the members of the committee has informed me that he was going to write up a proposal, an official proposal based on my proposal for adding arrays to C. I don't know if he's progressed with that or what's happening with that, but as far as I know, he hasn't submitted an official proposal. However, the idea is really simple, and if anybody wants to do it and make it in an official proposal, that would be cool. It wouldn't be that much work. I actually proposed adding those arrays to import C, and I got rather strong pushback. Why are you spending your time improving C? And you should be spending your time improving D. So I kind of want to do it as a proof of concept thing so that, you know, the C people would see that this is a easy change. It fits right in with the compiler. It's not going to break anything, and it will solve the buffer overflow problem in a simple and effective and admittedly D-ish way. The proposals, you know, various people have implemented safe arrays in C, but always with a truly execrable syntax, and these syntax is just so trivial. I don't understand why they just don't switch to the D syntax. So anyhow, I'd love to see it in C. It would certainly make interfacing with C a lot easier.
I wanted to ask a question about this legacy code again, because I guess the reason why you were removing these old features or whatever we call them was to make the language more lean. Do you think that in the future the language will you be able to develop new features just as fast while supporting old legacy stuff? And what implications will it have on like 10 years if you continue to support old features?
That's a great question because it's taken C like 30 years to deprecate some really, really bad features. And they're finally getting around to getting rid of them. I hope we don't have to wait that long to get rid of bad features, but we are going to have a way to say with the additions thing to say, give an error on all use of bad features. So, and it will be opt-in. It won't be on by default. But for the people who want to modernize their code, they're not going to have to deal with the problems with old features because we're gonna help them with that. We just don't want somebody who's wants to use a library on Dub and the original maintainer has moved on to other pursuits or got hit by a bus and it doesn't compile anymore with the latest compiler and people get angry, and we just want to stop that from happening.
I think in 10 years' time, what might happen that is a trade-off, obviously, is increased complexity of the compiler because you'll have to have code in there to handle more than one edition, obviously.
Yeah, we're just going to be stuck with that. I mean, the compiler is going to get more complicated. You all saw my presentation the other day. One of my efforts is constant refactoring of the front end to trying to make it stupid simple so that we can handle more complex scenarios with it.
Cool. We have a question from the internet. Serg is asking Matthias, what is the main thing you think is stopping the ecosystem to start increasing exponentially?
That's a very good question. I think it needs to reach a certain critical size. At the moment, we're missing some basic tools in Phobos, and I used to think that they shouldn't be in Phobos, but I changed my mind thanks to Andre. Deserialization library, XML parsing, better JSON parser, YAML parser directly in Phobos so that people don't have to find it. Essentially make things, makes the basic there and let people build on it.
Anybody else have any opinions while you're up there? You've all been involved in D for a while. You must have an idea of your own.
About what's stopping wide-scale adoption? Marketing.
Yeah, I was about to say more blogs. Yeah.
More articles, more, watch the news groups when they talk about programming topics. And, if there's something appropriate to say about D, mention D. I mean, it definitely works and gets attention. And I do it all the time. And sometimes I get, oh, there's Walter again talking about D, but that's what you got to do. And, I try not to be obnoxious about it or anything. Just bring it up in casual conversation on the internet. I use my Twitter feed is dedicated to talking about programming, and I try to say interesting things about programming, but like with a D, the examples I give just happen to be in D. And it's got around 6,000 followers, which is not great, but it's not bad. And I encourage everyone who's interested in improving the scale of D to use Twitter or other social media to talk about what they're doing with D. It doesn't have to be bragging. It doesn't have to be, smarmy or a hard sell or anything like that. Just talk about your programming work. And, oh, by the way, it happens to be in D. And you don't make a big deal about it. You just talk about the cool things you're doing.
Yeah, okay. Well, here's my suggestion. Hear me out, hear me out. The official D-Lang TikTok. Come on, we must have some meme lords in this community. Can we have a D-Link TikTok, please?
I'm cringing just thinking about that. Yeah, where's the gong?
Yeah, can we not get Chris to run that D-Link? No thanks, we've had enough of those jokes, thank you. Sorry, but no.
How much more refactoring does DMD need to do to be able to be packagized?
I did not catch what you said, Nick.
How much more refactoring needs to be done for DMD for it to be able to be packagized?
How much refactoring?
Asking about packages again, I think, in the DMD source code.
Well, I think you'll be pleased to hear, Nick, that I've been able to take a number of modules in D and cut way back on the number of imports they make. So there is some progress in that direction, although they haven't gone as far as putting them in packages, but at least trying to move the source code away from every package or every module is importing every other module. They really want to get away from that and do better encapsulation and containment.
After having completed the Ivy program, what's going to be the next steps? And will you guys be sharing your Ivy statements and that of the D-Language Foundation? Yes, when I get back from vacation, I'm going to be posting our Ivy statements, and all of us have personal Ivy statements. We have I can go ahead and give you the Foundation's Ivy statement now. You know, the D-Language Foundation exists to enable the realization of ideas by shifting the way programmers think. What does that mean? It means that every goal we set, every task we set out to do, we measure it against that first part. Does it enable the realization of ideas? If it does, it's something we need to consider. If it doesn't, we're not even going to think about it. We have to look at existing features. Is it preventing people from realizing their ideas? What does that mean? If you're having problems with bugs and error messages, we need to make that a priority, right? Before, we thought, oh, you've got all these long error messages. You know, we never prioritized reducing the number of error messages or deprecation messages. Failing to build old source code, that's not enabling you to realize your ideas, right? That's why Walter decided we need to support old source code. We need to undeprecate these deprecated features, okay? That's what that means for us, all right? It's just a tool by which we evaluate what are our priorities and how do we enable people to use D and our whole ecosystem to build their ideas, to make their ideas a reality. That's it.
Yeah, when we talked about our Ivy statements in these coaching sessions, I was surprised. I really didn't know why the other people were there working on D, and I was surprised at the diversity of motivations they had, and it was a real eye-opener for me. And knowing people's Ivy statements allows us to allocate our tasks and resources much more efficiently than what we were doing, because we can, you know, match the person who's excited about a particular thing with a task that fulfills or fits in with their particular excitement about it. I mean, I find certain kinds of jobs, you know, like I don't really want to do them, but sometimes there's somebody else who really wants to be doing that kind of thing, and I shouldn't be doing that. He should be doing that, and vice versa. I shouldn't be trying to push them into doing something that they really don't want to be doing.
And you know, Walter has often said that when people come to him and say, I want to work on something, what should I work on? And he gives them a list, and then they go and work on something else.
Happens
right?
every time.
So learning what we're learning about Ivy, we're learning how to talk to people to discover what their Ivies are without ever saying, hey, what's your Ivy? You know, where are their interests, where are their motivations, where are our interests aligned? And that will help us onboard new contributors more easily, I hope. And you know, I do want to say that Ivy statement, that Ivy vision statement that we have, it took us a long time to get there. Yeah, about 3 or 4 sessions, I think, because none of us could get past the fact that the D-Language Foundation exists to manage the D-Language. I mean, right? It says it right there on our website, right? That's why the D-Language Foundation was created. But Saeed kept stressing, the D-Language is a tool. It's a tool. Our YouTube channel is a tool. The website is a tool. Our whole ecosystem, it's all tools, right? So it took us a while. Who was the most difficult, do you think, Saeed? Who did you have the most challenge with? Who were you most challenging to get over the hump? Who do you think that was?
Like who's Ivy?
No, to get to the point you were trying to get us. See, he didn't tell us this is what it is, this is what it is. He was pushing us in the direction, asking questions. You know, what's this, what's this? And we're like, oh no. You know, and he finally got us there. Who did you have the most, who do you think took the longest to get there? I don't want to put you on the spot, but you know.
Answer carefully.
Or don't answer at all. Like, hard to say.
You don't have to answer.
No,
Well,
it's
maybe,
just, yeah.
well, I can't say hardest, but it took a long time because we, you know, it's just what I said in my speech, right? It's just think of an iceberg, right? It's quite visible and tangible to see. Of course, it's about the language. What else is there, right? But when you really dig deep and you understand, okay, what is the language about? Why do we even have this language? Why is it so different from any other language? Like, what distinguishes D from any other language, right? And then you go deep and you understand that, well, there is this set of mindset and principle that's behind D. Like, why did Walter even create this language in first place? That is the core value behind the D language, I believe. And for the whole organization, D Language Foundation, to realize that it's becoming something, it's moving towards something. And for all the stakeholders, especially the contributors, customers, for them to know where that direction is, where it's moving towards, and where everybody else is moving towards in their life, and how can this be aligned, that's deep work. So that's why it took long, really, like sessions. Even with the individuals writing their own IB statements, I believe at the end of the workshop we didn't have, like, we had like the first version or the second version. Right. It keeps evolving as people evolve, but for the foundation to, I believe, realize that D as a language is just a tool, right? It's just a tool to move towards something like a big vision, like a grand vision. And what is that? And it wasn't my place to even answer that question. It's your foundation, it's your organization. My job was to ask questions.
And you're very good at that.
The reason, you know, people would ask me, well, I want to contribute to D, what can I work on? And I would give them a list of things that needed doing, and they would do something else. And do you now see the fundamental failure of that approach? Is I neglected to ask, what kinds of things do you want to work on? You know, there's all kinds of different topics. I failed to ask, well, you know, what floats your boat? And if they told me that, then I could find a task that fit their interest, but I failed, it never even occurred to me to ask.
If I may add something, we do use the word Ivy, and like fundamentally what it is every single person, like all of us, we're going from our point A to point B in life, right? There's a reason why you're all here. We are all here. There's something in it for us, whatever it is. And wherever we are going from this point A to our point B, whatever that is something that motivates us. That's why you are all here and why you spend so much time contributing to this language. So knowing what that is and what is it that you're moving towards is what gives the foundation the idea of what every single person is motivated to do. And therefore, trying their best to align whatever that needs to be done for the organization to move toward that vision, right? Like who is doing what. It's not just about doing things, it's more about certain people doing certain tasks is going to help them move towards whoever they want to become in their life. In their point A to point B to point C to point D, even for a short time. Does that make sense?
We've actually got an online question for you, Saeed, from Ricky. Now that you have spent a bit of time with the wider community, have you observed any bureaucracy that we could remove to improve our ability to improve the ecosystem?
Me? Hard question because I don't think I've been that involved with like that level of detail to exactly know what that is, to be honest. I've been involved mainly with I would say more of a low resolution map, like the vision and everything. I would say that's maybe Walter can answer that question better. Am I right?
Well, in our meetings, we never really got involved in how we were doing things. You mainly had us talking about what are our goals and what direction we're going, not how we're going about it, or how our organization worked didn't even really come up much. So it was more goals and methods rather than our organization.
But I can just say this: once you have that vision, then what you do is there are lots of things to do, right? And then you set some big goals that are all aligned with that vision, and each goal breaks down into smaller goals, right? That's just standard. But what needs to be done is every single goal, no matter how big or small, as Michael said, is it aligned with that vision? Is it going to help the organization move towards that? If yes, that's the priority. If not, maybe not now, maybe later, maybe never. Yeah, if that helps.
Already streamlined things because I realized with my Ivy statement what I really didn't want to do instead of what I did want to do. And now I just delegate pull requests to Razvan and Dennis. And I know that if I need to look at something, they'll tag me and I'll just look at those instead.
And I can say I actually had 2 Ivy statements. The first Ivy statement I had, we had a session later saying, based on your Ivy statements, do you know what kind of task to give this guy, right? And everybody already knew what kind of task I would do. I'm the guy for the blog, not, fixing the bugs. They already knew that. But based on my first Ivy statement, no, that wasn't that. But I had to change it. But that first Ivy statement did help me realize I really, I don't want to be teaching English so much anymore, right? And that's given me more time to work for the D Foundation. So that's a benefit from my perspective.
I guess this isn't directly Ivy related, although it helps to have a it's related to a clarity of vision. Is the one thing that comes to mind with regard to editions? It's something that I'd quite like to see tried, but we've been somewhere between bad and hysterically awful at basically achieving our goals. So what are we going to do to actually make
well, first try a spec
and what?
Basically work on that and work out all the possible ways it could go wrong because going right is really boring, right? If it works, it works. So it's what could go wrong? What we need to take care about? Maybe there's things we can't do for whatever reason. So that and if you're concerned about that and you're volunteering to help publicly, I appreciate it.
I can. Hang on.
You can,
but I must. But what I mean is that we need to carefully. We need to make sure the feedback loops are there such that it actually happens, basically. And also we may potentially need an IV, pun intended, of like crack cocaine or something to make it.
The feedback loop would be messaging me in Slack and getting a reply, so.
I do that sometimes.
Yeah, I would like to add we've already been somewhat doing additions in the form of preview switches, and we have been successful at trying new features without breaking existing code using that. But we've been unsuccessful with making users adopt the switches and convert their code. And I think a big reason of that is that those preview switches, like they're hidden somewhere in the command line, and you have to configure your build system and coerce other libraries to also use the switch for compatibility. And the fundamental difference with additions is that you just annotate the module, like, oh, I want this module to have DIP 1000 checks, and then you can incrementally add DIP 1000 without, using that as an example, without having to fiddle with all these DIP 1000 flags in all the configurations of projects. So we'll have to see how that works out.
All right, we have a question from the internet here for Attila. What happened with standard version 2? Is it gone or is it just stalled?
No, I think that, you know, SED version 1 needs to happen first, and it hasn't because there's still things in experimental. And there's been a few concerns about the API of allocators and a few other things. So to be honest, that's what I want to be working on and moving that forward. And then I think we can think of SDV2. I don't think it makes any sense to do, you know, to put the cart before the horse, as it were. So that's it. I think allocators need to be finalized first, and then we can think about that. I don't think it makes sense to move forward before.
So, seeing as we're not going to be removing features in order to make sure that people's old code keeps working, and then we're going to have, I guess, additions that help solve this problem. What is a feature that you can think of that you kind of like to get rid of, but actually will cause an ongoing problem for complexity in the language or complexity in the compiler? Because the argument is always, oh, but if you can't remove the old stuff, the complexity builds up, blah, blah, blah. Now, to some degree in users' code, they can manage this by just not using the old features that interact in stupid ways, or we've got introspection abilities to prevent, you know, your new code interacting with old horrible features in some ways. But the compiler doesn't have that luxury. It has to keep doing everything, right? So, yeah, what's an example of a feature that might actually cause us a problem here?
Safe by default.
Okay, so that's a change that you don't know quite how to make without breaking stuff, right?
Yeah, you can't make the change without breaking things.
Sure.
It's by default.
Yeah, no, okay. So that's a new addition or a new change. Is there anything that you would like to remove that, you know, any of these things that have been deprecated that you think it's actually going to be a real weight dragging behind you to keep supporting it?
I want to remove the complex number support because it's a lot of complicated code, and I like to just get rid of it. Complex numbers can be properly supported with a library type. Why burden the internals of the compiler with it? And so I'd like to get rid of it. Is anybody here actually using the native complex number support? Yeah, it may actually be already dead. Dead as in there are no users of it. If that's the case, I would probably like to just, you know, turn it off and get rid of it. But I don't really know if it's, you know, most sincerely dead yet.
Classes. I'm only half joking. Kind of, sort of.
I think there are some features which are problematic because they're so ill-defined. Traits compiles comes to mind. And like it's used a lot and often in benign ways. So we can't just remove it without offering a replacement. But you can create, if you want, such crazy contradictions with, oh, if this member doesn't exist, declare it, and now it exists. And then if you have two of those blocks, you get a compile time race condition, which traits compiles does the compiler see first, and then that member gets added. And that, yeah, it gives a lot of complexity in the the way everything in D might reference every other thing. So yeah, that's something I would like to get rid of, but it's going to be hard to do.
I would also add that alias this, especially for classes, like if you look at the implementation, because it was underspecified, basically almost every file that does semantic analysis has a special case, at least one special case for alias this. So it has extended like cancer all over the code base.
And for me, extend C++ with an identifier.
What?
Extend C++ with an identifier for the namespace.
Oh.
Same thing as last year.
I have a question for the panel. Now that you've all gone through the Ivy workshops and all that, has it increased your enjoyment of working on D? Are you all happier people?
Yes.
Yes.
I'd say yes, not necessarily because of Ivy, but because I feel we're moving in a more productive direction with D. So I think Ivy has the potential of making us much more successful as a community and as a language, and that makes me feel good.
Well, also the workshops and what came from that, and you know, we've been doing these planning sessions since then. Everything that's come from Ivy has improved our working relationship quite a bit. Before it was really stiff, you know, not formal, but just, you know, standoffish. Now it's very casualish. We're all very casual with it now. Would you agree? Yeah.
Yes, I think it has improved significantly, and that's really nice. You know, I regard the foundation members and you guys all as our dear friends.
Yeah, but the bigger thing, that has helped us resolve decisions and disagreements in our meetings and our planning sessions. Before, we could go an hour or 2 hours talking about you know, things and arguing and disagreeing, but now we just get to the point and get it done. That's been a big benefit.
Yeah, now we have a weapon. If we're arguing about something, we just go, does it fit the Ivy? And if it doesn't, then, you know, we don't have to argue about it anymore. We can just get rid of it.
Yeah, I mean, that's a pretty big, you know, yay, Ivy thing. So I should just point out, we do have the Ivy workshops tomorrow at the hackathon. If you are interested in doing them, speak to Mike afterwards. Cool. We still have time for a few more questions. I did see a hand here.
I saw there is a like CI pipeline to test D-Lang like new features on a selected subset of DAB projects. So my question was, I mean, it was triggered by this like complex numbers informal poll in the audience. So like, I mean, is there a plan, for example, to just build all DAB packages?
Yes.
Yep. Okay. And I mean, like you can test new
basically
features.
The issue there is figuring out which ones build and you test, because otherwise, you know, there's dead projects. There's, yeah, the challenge is getting a list from code.dlang.org of things that make sense to even try. But yes.
Yeah. I'd like to basically just make a note as to on the various answers to John's question, which is that with things like complex numbers and the C++ stuff is slightly different, but they're kind of in a category where they're things that we should get rid of because they're stupid or because they're unnecessary, but they're also, from a complexity perspective, they're actually quite cheap. If you think about it as a kind of as a tree or some kind of hierarchical structure of the complexity in the compiler, if you get rid of complex numbers, you can get rid of a bunch of stuff in the back end, but you still have, you know, floating point calculations and so on in the back end. Whereas I think Dennis's answer is much closer to on the money as to what we actually need to do. And the answer, for example, couldn't be, oh, we're going to remove traits compiles because it's a fundamental idiom in the language, but we can add things to replace that, which are more specific and thus easier to compile, because the idiom of I'll just try it and see if it fails is actually extremely general, and thus subscribes to effectively complex, like whole scale complexity in the compiler. So, for example, I've actually implemented. I think Steve mentioned it on DConf in passing once. Effectively, a compile time scope guard. So you have like static scope fail, and I've implemented that. And you can, I think Andre was wondering about like catching compile, having static try before, for example. So this is the kind of thing where we have to be clever and invent our way out of these problems versus just trying to find cheap wins that are worthwhile but frankly don't actually matter that much in terms of how the language is actually used. And for the record, the complex numbers have been deprecated for a while. I think Ian did most of the, as far as I'm aware, I think did a lot of the work to get the library ones to the same, generating the same code, because there are some subtleties in how you actually want to do like complex division and so on. But they've been deprecated for a while, and we can, I think, very easily, they could be a very good example of something we can do with additions as a toy. That there isn't really a question.
To comment on that, people have been asking occasionally if traits compiles could output the errors if it encountered one. But as a compiler developer, I really don't want changing compiler messages to be a breaking change. So if they just get the raw string, they could test against it, and then if I just fix a spelling error, it could break build guide, especially if you expand it to everything. So that's one thing to be wary of by making traits compiles more expressive or something like that.
If the language is changing, it would be nice to have some way of doing a linter, so you can say inspect. Okay, maybe you have to have use this instead of this, like the deprecate thing. It would be nice to have something like this.
Yeah, I think the issue with that people brought up is string mixins and things. So it might depend on the context it's being used, and you might not be able to find it. But that doesn't mean we shouldn't try to do the ones we can, I guess.
Well, I have a couple of online questions before we get to Bruce over there. This one is from Serg to Walter. At what point in time, what would it take to make you think that, now we are ready to discard dip freeze?
Discard dip freeze?
Freeze as in, frozen freeze.
Oh, I can answer that one. We'll be getting the dip queue going later this year, before the end of the year. That's coming soon.
Right,
yeah.
right.
Well, we're not going to be able to fix all the bugs. Okay, there's always going to be something wrong and something new coming up, but we kind of, I think we'll know when we get over the hump with this, and we can start entertaining enhancements to the language again. But right now, we want to stabilize and get the worst of the problems dealt with.
Okay, next online question is from B2Her, and it's directed at Saeed. And the question is, do we all have to be in the Ivy thing so that Ivy works?
For the Language Foundation or general?
Well, just anybody in general. If somebody wanted to use Ivy in their day-to-day life, if they did Ivy, could they apply that to their day-to-day life, or does everybody need to know what Ivy is?
No. I mean, you can, yeah, absolutely. You can use, well, Ivy is your ideal vision of yourself, right? So, and as people, there is not only one layer to us. We have multiple layers. We're multiple people at the same time. So we have professional ideals in our mind. We have personal, what kind of a person I want to be as a human being. What kind of a relationship do I want to have? What kind of a friend do I want to be? And for each and every one of these aspects, you can write an Ivy statement. We actually have names for them. We have professional Ivy statement, which means professionally who you want to become. a personal IV statement as a person who you want to become, and so on and so forth. You can have a family IV statement. What kind of a family do you want to build? So you can write all those, and you don't have to share it with anybody if you don't want to. But I mean, the first thing that it does, it helps you have a direction in life and know exactly what kind of decisions you need to make and what kind of decisions you shouldn't make, and what's going to help you move towards whatever that you want to build. Because without that direction, all there is are just goals, and then you hit the goal, and then now you have accomplished that, and then now you have to go to the next one, and then the next one, and the next one, and it never ends. And if goals are not accomplishing something that helps you move towards something like a direction, then you're just accomplishing goal, and that's never fulfilling. So, yeah, did I answer the question?
Well, I would just like to add that I think they were talking about if you're in the D community, and as far as how Ivy applies to us, you don't have to care about it, right? You can just go on doing what you're doing and not even worry about it.
That's what I asked at first. So regarding the D Language Foundation, like if the question is, do I need to have an IV statement to be able to contribute to the D Language Foundation? Of course not. But if you do want for everybody to know what motivates you, so that they can actually put you in a situation, create an environment, an opportunity for you to actually be motivated and do what you really love to do, well, I think that's a good idea to do that. Otherwise, you don't have to.
My question is with respect to at least perceived balkanization of the language with all the attributes that we have. You see this particularly when you're writing libraries and people saying they have to adopt the no GC hair shirt kind of a approach to libraries. And I was wondering if there is some kind of consensus as to is that even a problem, and if so, then kind of how should we move forward? I'll note one thing: that it seems like the ability to make the runtime easier to port is a pretty big deal. Once you got the runtime easy to port, then it's like, well, why wouldn't you have it? That kind of a thing. But I was just wondering, just generally, what's the feeling about? Is there a balkanization type of issue, and if so, how do you see it? How do you see it being resolved in the future? Because huge benefits in terms of composability and reusability and so on, I think.
That's sure a great question, and something like better C's. Some people say it splits the language into two, and I don't really see it that way. It just seems like better C is a subset of D. And you can make a library work with both better C and with regular C, with regular D, just by writing to that subset. That just seems straightforward to me. I don't see a point really in having two versions of the library, one with better C and one with not. It's just, if you want it to be usable for both, you just do it in the better C subset, and it's going to work with regular D too.
You can absolutely handle the permutations manually. People do that. That's what they do currently. But what I'm saying is that leads to composability issues. Essentially, you have to be aware of this, and like essentially, who's my client? How are they going to nest it? I don't know. I'm not a big time library writer at present. I'm just kind of echoing some of the stuff I hear from Ricky, and it's like, wow, that sounds pretty bad. But I understand your position. I think that other people find it a little painful still.
Well, part of your question was is it a problem? And I think, too many attributes, absolutely, because you have to write them, and it's a pain to write, it's a pain to read. I think in terms of how do we deal with it, probably with more inference. And instead of having a human have to do things, just let the compiler do it.
Yeah, Till, you had an idea yesterday that you talked about if the body isn't present, then it has to be explicit or something. I mean, that was an example of the kind of things that I was hoping were kind of in the mix and being thought of. Yeah.
Yeah, no, we've been talking about that.
I think a way for better C to like to reduce balkanization with better C is to remove the underlying reason why people use better C, because it's not always because like they have to because they're on an embedded system or something. It's also sometimes because the regular executables of D are too big, or the runtime doesn't work with shared libraries, or it's not ported for WebAssembly. And if you can make that happen, then people don't have to use better C in the first place, and that would reduce balkanization a lot.
Yep. So I heard that you guys talk about the reducing the breakage and all of that, and I want to talk about that a bit more, because on my side, one thing I've been working on quite a bit is writing tools for D that people can use, like code formatters and stuff like that. And what has been a recurring problem is not the feature that have been deprecated and removed from D, but rather the feature that have been added over the years. And sometimes they're breaking change in ways that are more or less subtle. If we go back to the whole attribute stuff, for instance, if someone starts sprinkling no GC over their library, then suddenly you cannot interact with it if there are any kinds of callbacks or whatever. This kind of addition actually in my day-to-day practice causes way more breakage than any kind of removal. So I wanted to know if that's on your radar, if there are plans to handle that kind of stuff, because like that's a real problem. Or at least if there are plans to build them together, because one thing that's happening is like, oh, in that version we make throw an expression, it's not a statement anymore. And in that one we had no return. And in that one we had like this special syntax for contracts, right? And in that one, and all those changes are positive, right? They are better than the thing before. But that means that like every 3 months, every single tool breaks, and we have very poor tooling in the D community. And I think it's one of the main reasons, right? Because if every tool breaks every couple of months, then well, we don't accumulate them, right?
Well, I guess to sum up, if we add a new keyword, we break code or break the tools. Okay.
Update the tools.
I don't see that we have much choice about that.
DMD as a library?
I don't see a way around that. If you add new features to the language, you're going to break tools. What we're trying to do is not break existing code. But if you add a new construct to the language, like, you know, C11 added the underscore generic syntax, I mean, you can't help but break.
Yeah, so C, C++ are a good example of, I think, a better way to do that, because they have their big upgrade every few years, and then bundle all the change, all the new stuff that they add in that single release. And now, if you're moving to C11, you're the tool writer, well, you're going to upgrade your tool for C11, and then you have a few years in front of you to do whatever else. And, you know, they're going to be C, I don't know, 23 maybe. and you know, you're going to make a big upgrade then, but, you know, in the meantime, everything kept working, and the ecosystem can accumulate tooling.
That's additions. That's what we want to do with additions. To essentially bundle changes at certain point and allow you to choose which one you use.
I've also done some work so that the Lexer can be built as a standalone module now, and so can the parser. So if you're building a source code that manipulates source code in D, if you use those, you should be, you know, inured against syntactical additions to the language. Your code will still work, or your tool will still work. I hope that will be a result of this. If you build your own Lexer and build your own parser, well, there's little I can do to help with that. I think it'd be nice you know, we could all use a common lexer and a common parser, and that way we're not breaking the tools.
All right, I think we can do one more quick, good question from the audience and then wrap it up. So who's got a quick and good question? Not accepting bad questions, second-rate questions, out, no way, no. Who's got a good one? Anyone? Here we go.
Hey, well, at least I hope it's a good one. I guess it's a question for all of you. Where do you want to see the project evolve to in 5 years? I know it's a difficult one, but what comes to mind?
Well, we're going to start talking about that tomorrow at our planning session here.
Okay,
but I think Robert has something to say.
Let's park that then.
Yeah, I think it should be difficult to get tickets to DConf. Like, this room has to be packed to the brink.
That's right, world domination.
In 5 years, I want to see DMD work like the neat compiler does. That's what I want.
Yeah, honestly, one of the reasons why I always highlight new speakers is because I think we should have new speakers all the time, not just, regulars all the time. So the more new speakers, the better, because that itself is an indication of the health of the community, right? So, yeah.
One thing I'd like to see for our commercial users of D is that they're making money because they're using D. I mean, I want D to be a money-making machine for all you commercial users out there. I want it to be your secret weapon, your way to be, for your organization to be successful.
Nothing
yeah,
else?
not much to add, just grow the user base and make D just the best language.
There it is.
I think mass agreement of being the best language is what he means.
And I want to see YouTube full of D videos. Yeah, I want to see hundreds and hundreds of D videos, thousands. Yeah, get busy.
And similar to Robert for me, I want to see the same faces in 5 years and many more.
Cool. Final question for the panel. You looking forward to beer tonight?
Yep.
Absolutely.
Especially since I don't have a talk tomorrow morning.
Right. You're one of those guys. Okay, fair enough. All right, so that wraps up the Q&A panel. Thank you, everybody. And as implied, that is also the end of our regular scheduled programming for DConf. So it's been 3 long days. How has it been, everybody? Great. That's the end of 3 days programmer energy. It sounded like a golf clap. How was it, everybody? All right, quick show of hands based on this year's content. Who would come back next year? Pretty much everybody that doesn't have their hand in their bags. Excellent. That's a pretty good sign of confidence that we did this year. Good. Cool. So thank you to all the speakers for doing that. We could not have done it without your talks. Thank you to the maintainers of the language so that we have something to talk of. Thank you to Saeed for letting us all know that Ivy is pretty good and everybody up here agrees. Who else have we got to thank? We have the AV crew who, if we didn't have them behind the desk, geez. Yeah, the guys back there, Harry, Matt, Canyon, Tim, and Patty, just, say thanks to them on your way out and make sure that they're appreciated. We also had Sarah earlier this week. Yeah,
right now at the desk. Eden is the one who's been out there by herself. Sarah
Yep.
was here on day one. Bright Space Events, they helped us plan everything.
Yeah, Eden's been our tireless laptop defender. You haven't seen it, but she's been there making sure nobody that isn't meant to be here isn't coming in. So definitely thank her too. Of course, there's a catering crew downstairs. Who are they? I don't actually know their name.
No. Eden knows.
Whoops. Okay, sorry. And then we've got our sponsors. Primary sponsor, Symmetry. Well, we all know Symmetry, right? We got Ahrefs, who are also a sponsor. And on the supporters list, we have Yukoro, Weka, and Funkwerk.
And last but not least, thanks to our amazing MC.
I don't do any real work, you guys do, so whatever. And thanks to everybody for coming. Applaud yourselves. There we go. There's that golf clap energy again. Come on, have a bit more self-confidence than that.
And I just want to say, before we leave, we want to get a group photo up here, but we got to be out of here by 6 o'clock. So
Yes,
as soon
so
as we wrap
everybody,
up here,
please come up to the stage right now.
Let's get on up here.
All right, needless to say, if you're tall, then please stand up the back. Can I say DConf? DConf. All right, we good? We good? Great choice. I made it. All right. And that concludes the main DConf. We do have the hackathon tomorrow, the Ivy workshops. Make sure you speak to Mike if you're interested. Otherwise, get out of the building. We need to be done in 15. Move it!